Hello. Good evening.
Video. Hello, Sarita.
Yes. Is it visible?
You are visible, but wait. I will give you as a co-host. Hmm? You share once, Sarita, your screen and all. No?
Yeah.
Yeah.
Visible,
Document.
right?
Yeah. Yes. Yes,
Coming.
Sarita. Working.
Fine. My voice is audible, right?
Yeah. All good. Hello, Sarita.
Yes.
Sarita, once if we are sharing your screen, no, on the top, please switch off that annotation. Once if you share the screen, on the top, you can see the annotation. Here now I cannot do that. Why I'm not sharing the screen now?
Okay. Annotation is there.
At the time, once if you are sharing that time, you can do that annotation off. Okay?
Okay. On the screen. Okay.
Fine.
Let me check that also once. You don't mind?
Huh?
Let me check that also. Where I
Yeah.
should be.
Yeah, you do one. You do.
Yeah. Here annotate, right? Now is it okay? I switch off the annotate.
Yeah.
Hello.
Yes.
Is it still coming?
Yes, it is there. Done, Sarita. Good to go. Okay.
Okay. Thank you.
Sarita, no, it's you didn't do. I think we are doing annotation now. Can you do share? Can you share once again? On the top corner, you can see 3 dots in the Zoom.
Yeah.
In the Zoom, you are sharing, no?
Yes. More, right? You mean visible annotation for others.
Yeah, for everyone. That one you have to. Do
Okay.
it once.
Done.
We will try once again.
Yeah.
We will do some annotation. It's done, Sarika. It's working.
Oh, fine.
Yeah, fine. You can come back, huh? Okay. Dear participants, we will wait for 1 or 2 minutes. Let the participants join. Then we will proceed for the day 3 sessions.
Good evening, everyone. We are delighted to welcome you all to another exciting session of our ATAL FDP on next-gen innovation, AI blockchain, and AR/VR Metaverse for digital excellence. Yesterday, we had the privilege of engaging with two esteemed international speakers, gained valuable insights and hands-on expertise on AI-driven enhanced user experiences in virtual world and next-gen AI tools for innovation. Building on that knowledge, today's sessions are even more insightful and impactful. To begin, it is my honor and privilege to introduce our first speaker, Dr. R.C. Sarita, a distinguished scientist at CDAC Bangalore. With 25 years of experience spanning research and academia, she has made remarkable contributions in natural language processing, artificial intelligence, machine learning, augmented reality, Internet of Things, e-learning, and data analytics. Dr. Sarita has successfully executed multiple national R&D projects which is sponsored by Ministry of Electronics and IT, DST Government of India, Office of the Principal Scientific Advisor, National Mission on Education through ICT. Currently, she is working under DST-sponsored research on neural methods for voice search across ancient Indian Vedic Sanskrit texts. To name few of her R&D projects which has been handled under eminent government agencies are Mental Health and Normalcy Augmentation System from PSA Government of India, Adaptable E-Learning Accessibility Model for the Disabled, eSadhya, which is sponsored by DIT Government of India, and she worked on development of technologies for security testing and validation methodologies for cryptographic modules under MIT Government of India, design and development of systems and solutions for smart cities using Internet of Things, which is again sponsored by MIT Government of India, and augmented reality framework, which is sponsored by PAN CDAC. She also worked under design and development of context-aware mobile-assisted augmented reality framework for learning environment, which is sponsored by DIT Government of India. Another achievement is pilot phase for Takshya, technology for analysis of rare knowledge systems for harmonious youth advancements, a project which is sponsored by Pandulupi Samsodaka. Development of analytical tools for large scientific knowledge bases in grid computing environment, which is again sponsored by Deity Government of India. Swadhyaya project, Teach Yourself Sanskrit, which is sponsored by Rashtriya Sanskrit Sansthan RSKS New Delhi. So, the Sarita, other than these projects, the Sarita has numerous published papers which has been published under top international conferences and journals, mainly focuses on AI-driven word recognition, augmented reality, and mobile learning. Notably, her APSCHE sponsored CSEA 2012 paper on text clustering received the second best paper award. She has also been recognized with the CDAC R&D Innovation Award in the year 2016 and Scotch Award in the year 2018 for her pioneering work in augmented reality and AI-driven learning solutions. Her expertise and groundbreaking contributions in context-aware, mobile-assisted AR frameworks and AI for Sanskrit text processing have significantly advanced the field. Today, she will be sharing her insights and expertise with us. With that, I warmly invite Dr. Sarita to take over the session. Over to you, Sarita.
Thank you. Thank you, Dr. Sunita, for warm welcoming me to this. And thank you for giving the opportunity to share my expertise and experience with the audience here. Good evening, each and everyone. I think here so many professors, teachers, and scholars are available for this talk. I'm delighted to give my experience, which I have in generative AI and Google Vertex. Okay, and let me share my screen. And my screen is visible?
Yes.
Yes,
Yeah.
madam, it is visible.
Thank you. Thanks for confirmation. So now the trend is totally changed. So we are all depending on the machines rather than on the people. To trust the people means instead of trusting the people, we are trusting the machines actually for day-to-day life. So how we are trusting the machines? So that's what we are going to just give some insights upon that. So my agenda for today's talk is like introduction about generative AI and how it has been evolved. What are the types of Gen AI is available, and what are the challenges we are facing with Gen AI, and what is the Google's contribution with respect to Gen AI, and what is Vertex AI with regarding to, and what is auto generated Gen AI, and large action models, and how to implement this LMMs. Okay, so with that, the conclusion at the end. So this is a brief agenda of my today's talk. So let us see one small example where we have landed today in this fast-growing world. Previously in our legacy systems, the traditional programming, we used to type the features of let us consider a cat. We used to write how much it is a type of animal, legs is there, ears are there, fur is there, like that. And we used to write an expert system, actually an NLP based expert system, and identifying that this is nothing but a cat. Okay, that is the legacy systems we used to do as an expert systems. Later, with the advent of neural networks in 2012, it has come like we used to showcase two things, which is cat and which is not cat. So those images we used to train to the neural network systems in such a manner it can identify, it will formulate the rules by themselves, and it will identify which is a cat or which is not a cat. So for example, is this a cat? We are asking this one, it will tell whether yes or no. this what the magic from neural networks. So the systems learned in the neural networks how to recognize the input and how to answer it. But if you come the next point, if you come to the next stage where we have landed up at this point of time, is nothing but generative language models. So what it does is, we are not giving inputs or something. We are giving huge data set across the internet or across the digital data, whatever you have. It may be any type of data. So we are giving the system so you learn yourself. First read everything and then learn yourself. That's what we are giving the first picture. Then later, after learning the millions of data, okay, or millions, trillions, billions of data, then if you ask what is cat, it is able to tell what is cat there. This is what the generative language models we are land up. And we are totally trusting this type of models, the accuracy of the data, and we are using in day-to-day life. And there is a phobia also that most of the jobs will lost because of the Gen AI. But because of Gen AI, we will give a broader scope actually for giving a job opportunity as well as utilization of the digital era. The digital era we are making use very well for our action-oriented problem statements to solve. Okay, so with this introduction, I would like to give how this, what is Gen AI. So the generative AI models simply, whomever you ask first what is Gen AI means, they'll tell first LLMs. It is nothing but LLMs, large language models, they will say. What it does means it will understand and generate the natural language, how a person can able to speak. Okay, in similar manner, the text can be generated if you ask the machine. If you ask something query to the machine, it will answer in the natural language it will generate. But is it only for the textual? That's what we are stopping over there. So most of the people will be just using only the text point of time, but it is not that way. So even you can attempt for multi-modal Gen AIs also. So in that, what happens is it will generate the content with multiple modalities. That means other than text, it can be able to learn from videos, images, audio, whatever may be the format. The text is there, even that it can be learned. So that's what multimodal models, Gen AI models are available at this point of time. So if you want to create on the fly, I think you could have seen some reels on YouTube and everything. The images coming, it's generated by the machine. It's not drawn by some of the artists or someone. Correct, right? So how they are creating? So the Gen AI having a facilitation to create anything smartly, and it will visualize the format which you want it. For example, you want to create a story. So you write the sentences of the story. So the story, it will imagine and it will create the story on the fly. So that is what the Gen AI can do wonders. So this definitely will help in the education community for learning. Even if you come to certain SLD people, that means slow learning developmental people also, if you consider these type of technology will help them to learn and understand in faster pace. So how this Gen AI type of concept has been evolved over the years. If you see, it is not started as such in 2023 when GPT has come in front of us and giving a blast in the industry that no, everyone had now using chat GPT like that. So before that itself, the generative AI models has been evolved actually. So how it has been evolved, we will just have a glance of that. With Boltzmann machines in 1950s to 1980s, Boltzmann machines has been emerged and it used to supervise the learning by using deep learning models. It is very decades back. If you see that, so many decades back itself, it has been started the neural network models in 1950s to 80s. But later, the models used to emerge and utilize it in 1990s by giving a small application models like expert systems. That's what it has evolved in 1990s. Then later in 2000s, with advent of deep learning, the significant advances has come in the generative AI. But in 2010, early 2010s, the transformer-based deep learning neural networks has been emerged, and that will give literally a big boom at that point of time, because the systems used to learn that by using transformer models in 2010s itself. We will see what it is, transformer models and all, in the next slides. Just I'm giving a glance of you. And later, auto encoders and variational auto encoders has been evolved in 2010s. In the 10s. And 2014 to 18, the generative adversarial networks GANs has come, which will generate the data. The text can be generated with the GANs. So, what is progressive GANs? There are again progressive GANs also has been evolved in 2017 to 19. So, with GANs, let us consider it is creating an image from text to image. Let us consider in progressive GANs, what happens means layer by layer it is to be evolved. That means first it will give one first cut image of that, and later layers, in the next layers, the next cut of the image will be produced. So like that, progressively over the period of some 5-6 layers, it used to be evolved the image. That is nothing but progressive GANs. So like that, the progressive GANs has been evolved in 2017 to 19. But the industry has definitely has taken a big boom by releasing the GPT actually. So that the generative pre-trained transformer GPT has been evolved here, and which the second version was released in 2019, and third version GPT-3 was released in 2020 by introducing the API also available, so that people started using the GPT by accessing the API. API means application program interface. I think you know that link. Okay, so it has been evolved in 2021. But from 2000 in ChatGPT 2022, it was clearly announced that you can able to make use. Then the later version Google Bart also has been announced with Microsoft integrated a big with the GPT has been announced in Feb 2023, and GPT-4 was announced in 2023 March as such. So 2023 is a breakthrough, I can say, because so many other competitors also has come into the industry announcing their own GPTs, and comparison has come, and comparison has come from the audience also, that which GPT will be good to utilize it actually. So with that, Microsoft has come with the Copilot, and ChatGPT has been publicly released in March 2023. In by introducing Copilot, people used to compare with Copilot and as well as with ChatGPT we're using. Then later, Meta also started its version of a GPT called as Llama. So those days, even in 2023, everyone thought that Llama 2 Llama itself is a big boom because it is giving more accurate results compared to the GPT. But over the period of time, even OpenAI also has come into the picture in September 2023 and introduced the DALL-E. So one by one in the competitive world, they introduced their own generative AI models, and it has been sent this across countries in different languages. So in Bird has been now at this point of time it is available in 40 plus languages, and it is very will be using across 180 plus countries also. And OpenAI's assistance was evolved in November 2023, and with the Samsung also has released the Gauss AI model as such. So this point of time, the Google again take over that one by introducing the Gemini also. So first GPT, then now it has become to again now Gemini has come into the picture, and Gemini Pro is giving very good results compared to others also. So now Apple also has come into the competitive world, and it is giving an MLX framework where you can able to introduce all the models like foundation models, you can use it. But till now it is going on with the LLMs, generative AIs and all. But later it has in 2024, one more stage it has been crossed with rise of LAMPs, that is large action models. So by introducing a Rabbit R1, which has been introduced to the industry, that also. So with this, we can just have a glance of the evolution of generative AI models over the period of time from 1950 to 2024. So now little insights we can go through with what is the different types of GANs also in the upcoming slides. So we all of us know that language models, what is highly required is we need a prompt engineer who can able to query in the prompts that what do you want. Correct, right? You can ask, please write a product description. You can tell what is the cost price of this jacket, or we can ask what is the cost price of a particular model of a two-wheeler. So it will automatically compare and it will able to list it out. So how the prompt, the data, the queries has been will be sent to a large language model which can understand, and it will generate the corresponding text, and the text will be model output will be released, which can be able to prompt into the user interface. So this is what the large language model and the basic functionality of that. So, but foundation models, because in this industry, what happens is because each and everyone used to generate their own models, and they are making publicly publicly available with the open source APIs. So people used to use in their own daily applications also as such. That means any application, even enterprise applications, even banking sectors, in any other sectors also, in healthcare systems, everywhere people start using chat GPTs, or they are using their own LLM models by just interacting with these open source APIs. That means they are not doing from the scratch. What they are doing is they are just connecting to the open source APIs which are available on the internet, and that model will give the response to you, and they are directly they are incorporating into the applications. So with that, the purpose is served, and which will be very less effort for the application developers. So this is what the trend is going on. So all pre-trained models, pre-trained generative AI models are available open source. So people are using by using the API. So foundation model, what we can say it as in a large X models, because so many number of models are available with the deep learning models, which was trained on vast data sets. So many data sets it has been trained, and it is readily available for our daily use cases. So some of the examples of foundation models has been provided here, like Google has been provided Palm 2, Bird, and Bird, something like that. And OpenAI is giving DALI and GPT-4, and Meta is giving Llama, and Anthropic is giving Cloudy, and Databricks is giving Dolly, and together is Red Pajama, and Mosaic for MPT-7. So like this, so many other companies also which cannot be listed here, so are available for in directly uses of their APIs. Let us come concentrate that how to generate these type of models by self also. See, one is like uses by using ourselves, and how these generative models or different types are available. So how can we can able to use that? So the first, there are four different types I can say, okay, in broadly classified, like GANs, generative adversarial networks, and variational auto encoders, VAEs, and transformer models, and multi-model models is there. So let us see one by one what is very briefly. I will explain that what are GANs. So in the GAN model, what happens is, let us consider you want to classify whether whatever the data it has been generated by the GANs, that means it will create the data, right? It will create the text or something, whether it is real or fake, you want to classify, let us consider. That is the problem. So in the GAN, what happened is we have a generative model and we have a discriminator model will be available. So the input vector space, whatever data you have been trained for the GANs, the training data will be embedding into the vectors, right? So those vectors randomly it will select, and the generative model will create a synthetic example. That means whatever existing data, whatever realistic data you are giving for the GANs to train, it will not that one. It will create a synthetic data over there in the generator model. This synthetic data will be passed to the discriminator model for checking whether it is real or fake. But it will also learn by improving the feedback. You can give a feedback that yes, it is a true, it is a false, like that, so that the model can will be improved through feedback, and it can be explained. I think all of you can able to believe that nowadays if the data is not sufficient for training any AI models, people are using synthetic data sets because of lack of collection of the original data. Actually, suppose for example you got some thousand data set, thousand records of data sets are available, data set is available with you, but your AI cannot able to learn properly with the AI, with that. For example, images, let us consider some thousand images are there. With the thousand images you want to develop an AI model, even people will tell, madam, there is a small learning models also is available which can learn with even 500 also. But if it is more, as soon as the data is data is large, is available, the model will learn very properly with good accuracy. Because of that reason, we can able to create augmentation models. There are augmentation we can able to do, so that the synthetic data will be created based on the original data. For example, face recognition itself, let us consider. You could have taken your face from 3-4 angles. So you can tilt that images into different directions, and you can able to create that such type of augmented data, and you can able to increase the data sets. So that is one type of the thing. And by using GAN also, you can able to create the synthetic data from the original data. This is another way we can able to create. So that were the GANs. So let us see, concentrate on variational audio or auto encoders, VAEs we are calling. So variational autoencoders also provide it provides a probabilistic manner. That means it will give a probability that whether it can be feasible this much in the latent space. So here also encoders are there, how it is generator and discriminator is there. So similarly here encoder and decoder is there. I think it is like a neural network model where we have the input space, the hidden layers and available. So the encoder models can able to pass the input space to the latent space, and there the probabilistic models will identify it, that how probable the sample the distribution is happen to the output space. So like that it can able to generate. But where it will be highly utilized, this VAEs is for anomaly detection we can use it, and data imputation and denoising. So any data, if you want to noise reduction you want to do, or you want to change the data, instead of one parameter you want to remove and then do it. So such type of manipulation you can do it on the data, especially in imaging data. And semi-supervised learning is very good for VAE. And in the latent space manipulation, especially when you want to modify the images and videos. So I think when you are securing your data, like data security, you want to check when you are transferring in defense applications or any type of very sensitive applications. When you are doing, you can use this type of models and you can modify the image and then you can send it. So that what happens is, it will not, the real image cannot able to see, like a videos also. So data security you can maintain by using variational autoencoders. So the next type of the model is the transformer model, which most of them knows of this very well, because this is the heart of the GPT transformer models. So where this encoder decoder will able to give very good results for identifying context of the sequential data. So previously the data was totally discrete, but now the continuous data, that means it can learn the continuity of the sentence also as such. So in a sentence, the word should be in a sequential manner, right? So your transformer model can able to understand, and then with the self-attention models also, multi-headed attention models, it can able to remember the previous words and it can store it into the memory, so that the sequence can be maintained from the input space. So that's what the transformer models will do. Similarly, this will be highly, we will be using in machine translation models for converting from one language to another language. It will be modality, different modalities also, or text also, like scheduled languages and non-scheduled languages. So much of research under national language translation machine going on at this point of time, where all the traditional classical models was totally tuned into the neural models, and these neural models definitely helping them for translation from one language to another language. So we have been working, our team is working in even NLTM projects, where the translation from Kannada to Hindi and Hindi to Kannada, even to Sanskrit, we are working with the neural models by using transformers only. So that it will remember the sequence of the sentences so that the accuracy will be improved at the decoder, after the decoder. So next one is multimodal models. So multimodal models are divided into two. One is unimodal, another one is multimodal. This is the one small example which you can able to get by using. Let us consider you have given a description at the prompt that you have told that please write a description of a horse. Then the instruction will go to the generative AI model where it was pre-trained with transformer models or foundation models. It was pre-trained, the generative AI model, which will decode and give that the result is a horse is a magnificent animal that belongs to the equity family. So this is from text to text. You are asking question in a text format, and your generative AI model also is giving the result also in the text format. This is one modality, right? So in multi-modal, what happens is you have provided input as an image. Here, the horse image is there. So the prompt will upload the image, and your generative model can able to describe that one what it is. This is a horse in the after decoding from the transformer models or any other foundation models it could have used. And the result two is giving that this is a horse. This is one type of transformation. The second one is you can ask from the text. So when you give a text as an input to the generative AI model, it will decode and give you the image. So text to image is also feasible. The third one is you are giving a description of a horse and it is saying an audio about the horse. So here you could have seen as a result here, you can able to see that text, image and audio. Different type of modalities the generative AI can able to generate and give to as a result to us. So this what the multimodal models are able to support. So what are the benefits? Why we need this type of things very highly we are using means the benefits is like it will makes informed decisions. That means the decisions is very clear and it is very informed to us also in different types of decisions will be provided to us. Similarly, content creation and inspiration. So previous in olden days, the content writers will be there who can able to create the content and provide to us. But now the machines is going to create such type of content to us. So on the fly, you can able to draft emails, you can draft in concept notes, you can able to draft in legal papers, whatnot. Anything can be done by using content related thing. That is very inspirational by using Gen AI. The next one is the personal experience. Personal experience means it will remember the generative AI models will remember the past interactions of the person. That means what way you are tuned and what is your way of interaction with that. So your experiences will be recorded. So accordingly, the responses will be upgraded, and on the fly, it used to be recommended to you. This is what you should do it. Suppose you are not liking in some of the foods like sweet. I don't like sweet like that. You could have written on the on your prompt. Then it will remember that you don't like the sweet. So next time it will not recommend you that, or it will not give you the sweets related things. So such a personal experience will be recorded on the generative AI. And it improves the efficiency also. It saves the time, it saves the manpower, and it will give wonderful results to us in a short span of time. So that's what it will be very efficiency in all the aspects. The fourth one is automation friendly. So automation will happen on the fly. How can you say automation is happening? Automation in the sense means like here a process, any activity to be completed, it should follow some process. Am I right? So process means how the input which you are provided should be first denoising it, correct, right? It should be pre-processed properly. Then it should be relate which and all text should be done, and it should be validated, and it should be personalized, it has to be done, and it should be provide you as a result to you. So this entire all the steps will be automatically automation will happen, and it be friendly, it will be giving experience to you, and always it will be virtual guidance. So you cannot say that person is not available until and unless you have an internet connection. You can say that you have one buddy with you who can able to guide and who can able to take forward your daily life actually. So that way, the virtual guidance is very helpful in this. So what are the challenges? Is it everything is very good? No. There is always pros and cons are available in any technology if you see it. So I will discuss a little challenges, few challenges when you are using Gen AI. Number one is the data privacy. So personal things, usually what happens is when you are drafting a mail or when you are conversing something professionally or with anyone else, let us consider a judge or a defense person is interacting with the chat GPT and asking for something. So it will be recording on the background, in the background process, it will be recording all the things. Suppose he is discussing, he wants to verify something with regarding to the missile, let us consider. So you are disclosing about our own national missile details over there. So which is totally the privacy related thing. So data privacy will not be provided by chat GPT. So that is one of the challenge which we have to use it. Even for children also, they may not, they will be totally transparent. So whatever they want, they will just ask you, they'll think nothing will happen. But the only thing is, even our parents could not control. I think the chat GPT can control us, I feel, at each and every stage of interaction with the means with your generative AI models. Next one is contextual limitations of language models. Can we say that even though the general generative AI models are available for general interactions, for example, I'll give one small example to you. Let us consider I want to tell that I want to ask one sloka in Rigveda. Sorry, I'm taking an example which is our Indian heritage thing because I'm working in Indian heritage also. If I ask ChatGPT, you just explain one of the word, what I will give a word in Rigveda, well, the ChatGPT is able to give to us, or Gemini will able to give to us. I think some interaction is required. Have anyone tried like that in your own domain, which it fails? Not getting any response.
No, they're just texting.
Okay.
Not
Okay.
tried, no.
Yeah, please try in your own specific domain, like healthcare systems, very specific, or you go to our Indian heritage, very specific, or historical evidence is very specific. Then it may not able to understand what we are asking. Why means the AI models did not trained with such type of vast data. It could have grabbed the data across the internet actually, which is available, but not specific to that. Still, our Indian heritage data, if you see, it has been hidden in our own treasures only across the universities, across the national institutions, which cannot be this. So contextually, the limitations of language models is available. Not like you can the same. Suppose it has to serve for the particular domain also. It has to be trained on that domain. If it is not trained, definitely it cannot able to understand. So, for example, let us consider Ayurvedic information you want to chart. Let us consider which type of home remedy or which type of leaves or anything combinations I can use for a particular device. You want to chart for that. But if the AI model, the generative AI model, did not train on such type of domain, it cannot able to suggest you. That's what I want to tell you. So contextual limitations are available. So that's why nowadays what happens is they are making this conversational AI specific to the domain. Like banking domain will have their own contextual conversational AI will be there where it is. So similarly for financial, it is different. For healthcare, it is different. So like the domain specific contextual language models are available at this point of time. The third part is like output quality and accuracy. You believe that whatever it suggested is correct?
No.
Whatever result it is giving, no, we cannot trust that one. It will give a general recommendation or suggestion to us, but don't believe that 100% it is correct. If you follow as is whatever ChatGPT or your GPT it is showing to you, if you follow that, definitely you will be failed in that activity. So you have to use your human intelligence because the generative AI is helping us to improve ourselves also, or you can use certain general information from that, not with the specifics. So quality again it matters actually. So sometimes you could have seen that it will ask you whether the reply is relevant to your query or not. Yes means you can able to it will accept, oh, whatever it has been given is correct. Suppose you want to give a feedback that no, the result, the response which it is being given is not relevant as per your query and you want to improvise it, then This information will feed back to the generative AI model and will understand what it has been generated was not up to the mark of the expectations of the user. So it will again retrain it. So that's why here the quality of the output is not accuracy, because it is generating on the fly with the different combinations of the data, semantic relationships of the data. That is a thing. Now, biases in AI models. Even AI models, whichever is available, is having its own bias. So we cannot trust totally the AI model itself is giving 100% accuracy. The next one is, the last one is scalability and integration with existing systems. See, anything, let us consider you want something to retrieve the response. How long you have a patience to receive the response, you tell me? Hardly 2 seconds, 3 seconds, because I'm not telling about the minutes. Minutes, no one will have the patience to wait for the response. Am I right? So definitely people will have a patience of maximum 5 seconds. So within 5 seconds, the response is not able to display to the user. He will lose the interest to interact with the machine. So this is what even this is a UI even some guidelines are there. Okay, so according to that also, so the man expectation, the person expectation should be before less than 5 seconds. Okay, exactly 2 seconds is the best thing. 2 seconds to 3 seconds we have to give the display to the person. So such type of realistic applications has to be incorporated into the application so that you can be able to retain the user. That's the first thing. Second one is the scalability. Scalability, if you come to know practice here, that the backend infrastructure which is maintaining this generative AI models should have a huge capacity so that it can able to expand whenever there is a dearth of the resources at the backend to support it. So for example, let us consider it is having a like a supercomputers or distributed systems, what I'm saying at the infrastructure based. Nowadays, Kubernetes and all has come. So Kubernetes platform will be very good actually, where it can automatically it can scale down. So previously we used to suffer with the horizontal scaling and vertical scaling on our infrastructures, and that will not give the proper scalability at one point of time in order to address the public citizens, because the concurrency of users will be very high. The latency is very less amount we need to response actually. So such type of platforms is highly required in order to support the scalability. So we have to think this is also one of the point why when you are generating to a specific generative AI models, you have to think about the scalability also, and how to integrate the scalability into your existing systems. So that also should be considered. So what are the latest LLMs is available, like GPT-4 as we are using? This is only for advanced reasoning and usability. And Google Gemini is one of the most prominent one now because it is having multimodal capabilities with diverse data types like image, videos also it is able to support it. And Meta Llama 3 has have the high scalability as I such. It has a scalability. It has resolved the scalability also. Anthropic Cloud 3 is one of the safest and reliable. Safety and reliability also as matters actually. And Coher command R plus retrieval capabilities are very good in this. I'm giving the where it is very strong actually, but it does the basic features is been addressed over there. But in which feature it is very strong, that only we have highlighted here. And Microsoft P4, it was designed for accessibility with the diverse user needs. So even who are having accessibility issues also, the person with accessibility also can able to use this one. That is what the advantage of that. And Minstrel large 2 is also very good for strong coding support and large content window. And I think most of you, the software developers nowadays, they stop writing coding on the self. They totally depend upon this type of LLMs where they are asking, please give the Python code, please give Java code, means it is automatically creating a code and giving to them. They're copying and pasting and they are able to use it. But the human intelligence, definitely it is has to be applied in order to use, customize that for their own problem solutions actually. And BERT is one of the best the start it has come from Google, which can understand the contextual sequential data within the sentences actually. So these are the most popular LLMs available. And coming to the Google's one, now we have seen what are the broader picture in general, what are all different types of generative AIs are available and how it will help us, what are the challenges. But coming to only Gemini, means Gemini one of the thing which has been landed. So similarly, Google's contribution, how it has been evolved over the years. So that's what our concentration is here. So 2017, with the advent of transformer models, it can start the LLM revolution has happened. And 2018, BERT has come, okay, which is a groundbreaking large language model. And 2019, T5 has come as a text-to-text transformer models. So most of the machine translation from text to text, okay. So from any language to any language, if you want to do it, people are, most of them, they are using T5 models actually. And Lambda was also one of the very good model which can able to do the conversation too. And AlphaFold for structures of all known proteins. It was totally domain specific thing. That means if you have a genomic applications and you want to structure your genomes and find it out the known proteins inside it, and AlphaFold was very good. It will predict very well of that. So it is a domain specific generative AI model which is been available here. Like that, so many domain-specific generative AI models are available in Google foundation models as such. 2022, Palm has come. That is the industry-leading large language model, and BARD is the conversational AI model which has been introduced in 2023. Apart from that, Gemini was the best one at this point of time, which is giving good results and accuracy. And Imagen 2, this is for text to text, and Imagen 2 is for text to image. So this is one of the best foundation model provided by Google Imagen. So if you ask some sentence or something, it will create accordingly to the text and give to you. And next one is the Gemma open models are also available. And this Google's a new chip AI is there. This is a speech to text. So if you speak something, then it will create a corresponding text for that. So these type of different multi-model generative AI models are supporting from Google. Now, ma'am, how can we use all these things? What is my purpose? How to use for my problem solving solution? Is it, see, we don't have infrastructure properly at our own universities. And definitely what we are doing is we are going to use Amazon Web Services or Google services. We are using definitely because it will totally relax us from the infrastructure problems so that the services will be available on the fly to us. So that just like drag and drop how we are using, similarly, the models, you can able to drag it and use it. You can apply it and you can use it on your applications. And later you can monitor also how it is being utilizing for you. Based on utilization, you can able to pay. So it is a paid services, most of them. So most of the very good foundation models which are available in Google are paid services. Even unpaid things also is there. I think first, if you register in Google for GCP, that means Google Cloud Platform, if you register, it will give some $300 credits to you, which is free for you. Then later point of time, you have to pay for that. So that what available. So how to utilize the Google's cloud services for a generative AI that we are going ahead now. Okay, so let us, this will brief you actually how it will be done. You see here, I can ask like, I want to use Gen AI with Google. Okay, then as a consumer or developer. As a consumer means you can use directly BERT. But as a developer, if you want to use it, there are foundation models are available, as we have seen. So this foundation models, how to use it, whether it is from Google AI Studio or Google Cloud Vertex AI. So there are two different things where the prototype or independent of the developer is Google AI Studio, and a developer with the SLS means service level agreements are available with data isolation, security, and scaling all are available in Vertex AI. So that's why the developers will use Google Cloud Vertex AI in case of any enhancements is required for their applications. So in Google Cloud Vertex AI, there is Vertex AI Studio. Like Google AI Studio is different and Vertex AI Studio is different. And along with the Vertex AI Studio, it inbuilds model gardens actually. Model garden is nothing but the collection of all models, AI models are available. So garden means here they kept because of the collection. They instead of collection, they kept it as this one. So it is one party, three party, and OSS, open source models also available. That means they have collaborated with other companies also to host their models into the Google, so that in one platform any developer can able to use these foundation models for their purposive problem solving applications. The third one is Vertex AI search and conversation is there. So you can able to search across Vertex AI and it will also give the conversational responses like how the ChatGPT is doing, right? So similarly, it will also give the responses to you, and documentation of all AI is available here on the Google Cloud Vertex AI. I think this will give a glance for us why we are using the cloud, Google Cloud. Okay, whether we had to go for Google AI Studio or we had to go for Vertex AI. Okay. Now let us introduce now right time to introduce what is Vertex AI. So Vertex AI is nothing but a governance platform, I can say, end-to-end governance platform where the whole ML life cycle is available, which can able to build, deploy, managing your models, AI models on the Google Cloud. That means it is like previously, like if you have some drag and drop something now on your interface, it will be easier for you to interact it. As simple as that, you can able to use the ML in your applications. Okay, ML or AI models you can able to apply. So this is a unified platform for building, deploying, and managing the machine learning models actually. So this encompasses data engineering, data science, and ML engineering. All the three workflows are integrated together in the Vertex AI. So what happens is the developers or data scientists or data engineers who wants to work in AI models they have to ideate. They have to get the idea. That's enough. That idea can be able to make into deployment solution by using Vertex AI. So that's what people, if you have an idea how to implement or something, then the platform will give an access to you to immediately develop your solutions by using the Vertex AI. So you can prompting, that means in like how you are, I said, no, multimodal prompting, you can do it. That means through image, through audio, through text like that, you can prompt it. And that will give the generative AI models, which you have to use it also. You can able to select it. And after that, it will distill that one and give the results in the conversational way. So like that, it will able to do it. Apart from that, it will give LLM operations management also. That means which LLMs we have to use it. Okay, which is appropriate, which is image oriented, which is video oriented, which is a text oriented. AI models are available. All those things are available as a foundation. I'll give a little glance in the next slide so that you will be little familiar of that. So the key features of Vertex AI is first, number one is ML Ops tools. So these tools will automate, standardize, and managing the ML project's life cycle. And model training and deployment is there. So you know that some of the models are very custom to TensorFlow and some of the models are customized to PyTorch. But here, this AutoML models will give extensive support for you. It will not able to think that which type of customer models you are using. It will be, you can able to deploy any type of these models into your real-time predictions. So such type of facility is available. Next one is model evaluation is there. So the first, we can able to compare the models also, that which model is identifying better and better performing onto the problem statement. So that model you can able to utilize. So you can do the even comparisons. Apart from that, the pipelines, the orchestration of the pipeline. That means from the data ingestion, the data ingestion into the pipeline, from that part to the deployment part and utilization into the application. Till then, the whole pipeline can be orchestrated by using model registry. So you can able to maintain the models, their versions also you can maintain, and their deployment and the releases of that also. So everything you can monitor that orchestration by using model registry. The next one is the future store. So if a model has been engineered and has been centralized, you can store in the central repository for the future purpose, and you can reuse the same type of model again back onto that one. For example, let us consider you have a future extraction has been done. Let us consider on a particular set of data sets, these futures are extracted and kept it. The same future set, if it is saved into the central repository of the Google Cloud, same thing can be utilized for multiple applications, I mean. So multiple practical applications, you can use the same feature set. So such type of feature store is available under Vertex AI. So this is the overall, I can say, overall architecture, basic architecture of Vertex AI. In Vertex AI Studio, there is a prompt here. Okay, the prompt will take inputs like text, image, video, audio, document, any type of modality, and it will be passed to the responsible AI and safety. Okay, so it will think that whether the data is safe, data security is there, data safety is there or not. And behind the scenes, what happens is it will check the input rejected. If the data is not secured, let us consider to further process, it will stop over there at this stage of responsible AI and safety. Later, it will able to select the foundation models like Google models, tuned models. So there are some already pre-trained models are available. You can fine tune that with your own data set. Most of the people right now, the data data scientist engineers, first the start of the what they do is they will not develop the models from the scratch. What they will test is with the existing data set, what problem statement they have and what is the data set they want to do and what is the outcome they are expecting. They will check with the either predefined pre-trained models are there like Hugging Face, like OpenAI, like that Meta. They will go and check whether any pre-trained models are available supporting for this purpose, and they will fine tune with their own data set, because the models will be trained already on different data sets, not on your data set, right? So sometimes it may support, it may not support also. So the trained model, already the pre-trained model, you can able to select it and you can able to train on your own data set, so that that model can able to give the predictions or outcomes will be as per your target, what you are thinking. So that's what the tuned models are. Okay, and open models means open source models are available. No? So those models are also available in the foundation models. Next one is the partner models. So Google have some partnerships with the other companies. So those who has developed their models also has been hosted in the Google Cloud platform. So which is can be available. It will be price based will be there definitely. So price based or open models will be open source anyway. You can use it directly. So like that, foundation models are available. And from here, the model customization, you can able to do it. Okay, so what type of tune you can do in this one is you can tune, you can evaluate, you can deploy, and you can monitor. So these are the steps continuously you can able to do under Vertex AI. This is a wonderful actually support for the developers. Why means you can continuously tune the model, you can increase your data set anytime on the real time also, and you can evaluate, you can compare with other modules, and you can able to deploy which is the best giving. You can able to deploy it, and you can monitor the performance of the model also. So the whole orchestration is available here in the model customization that can be done. So from here, the RAG, so retrieved augmented generative one. So this RAG will able to give the response can be created from the ground functional calling, where the citation it will be checked and again it will retrieve back to the output. Here also, again, once the citation has been checked, whether it is perfectly correct or not, with what resource, what are the source it has been generated the response. See, when the response has been generated, it is generally just like that, it will not respond. It will check for the sources from where it has been taken and it has been checked that the response. So with the citation check only, it will pass through again responsible AI. You have seen this bridge here. The responsible AI and safety is the main big bridge here between when the request is passing to the Vertex AI for the foundation model. Similarly, when the response is reaching back to as a response to the user. So both there, the responsible AI and safety will play a major part. Okay. So the same thing was explained here. What is the prompt actually? This is, I have given for your references when we shared the slides. You need not go away from here. So here the prompt is there, no? The prompt. So prompt is nothing but one text box like that will come, whether it should be image or it should be voice to be recorded by using microphone, or it should be text. So such type of prompts can be given. There are some design principles for prompt design also. Actually, in what way we have to have. There are different types of prompt templates are available. So those prompt templates you can able to use it actually to appear in the user interface. So that's what has been explained here. So the prompt can contain text, images, videos, as I said, and other multiple modalities. And the response from the model is a practice actually. So that we are calling as a prompt design. So we have to design properly. So there is a prompt management tool is available in Vertex AI Studio. Okay, so we can able to manage that. So this is the way you could have seen here. Example, prompt gallery. There are so many prompts are available. See here, audio, document, image. So corresponding to the modality, you can able to search the templates. Means the prompt templates is templates or types and models are available. For example, here I am going to text. Let us consider. So the text itself, whether you want a question or answer question text or classification text or code, you want it, or extraction or summarization or transform or write or generate. So these type of task is available. So similarly, for audio it is different, for image it is different. Like that features are available. So which can be utilized it in the Vertex. And next one is the prompts are generative, right? So later it has to go for the models. So what are the different type of models we can able to use here? Means for Gemini API is there, the foundation app. The foundation models can be accessible through a managed API registry. So the APIs, which are all different types of APIs are there, means like Gemini API for reasoning, for multi-chart, in multilingual also, and code generation is there, multi-model prompts are there. Those are Gemini APIs. And image gen is for image generation or image editing or visual captioning. And MedLM, this is a specific domain specific API. So which will be used for medical question answering and summarization. That means some foundation models, that's what I'm saying. It is very specific to the domain specific, and the foundation models are only do certain type of tasks only, not enter all the modalities. It will not be available. So the models here, the overall models will differ in size, modality, as well as cost also. So if you are working for radio or some other modality, obviously it will be more costly when compared to other models. So all these models, the open source models, Google partners models, everything are available under Model Garden. So when you are searching in Vertex AI, you can search directly Model Garden where it is available. So the foundation models will be classified into these types actually. Number one is generative text. So it is a text language tasks actually. And generative chat means multi-turn chat. So multi-conversational chat, because it has to maintain the session. Here, generative chat, what happens is the session has to be maintained. So that's what ChatGPT or Gemini is able to maintain the session with the user actually. So that is a generative chat. And text to image, that is a single prompt. And API for text and images. So it can extract even simple semantic information from the unstructured data like images also. The next categorization is speech to text also. You could have seen here T to T, that means text to text, correct, right? Then text to speech, speech to text is available. Apart from that, we have even code generation. So the codes, the software codes also are available, so which can able to improve your coding and as well as debugging tasks. So these are all main classifications are there. You can see here the language based, image based, video based, documents based, and speech based. Language based, if you come, text generation, chatbots and conversational interfaces, summarization, text search and retrieval, translation across 140 plus languages, sentimental analysis, content moderation. Actually, you can recognize here, usually when we are doing some projects, we will do one itself as one of the research area for us. And we'll go deep insight for that how the domain specific problems can be solved. But here, the overall, the pre-trained models are readily available for text generation with respect to the language. So we can readily use it as is. You need not reinvent the wheel again back, because when the APIs are available, when the models, foundation models are available with respect to the language, so it is faster to develop the applications on the fly. Similarly, with respect to image generation, styling and editing, captioning, visual question answers, image recognition, classification, text and handwritten detection, logo and landmark detection. So such type of API models are available. AI models are available. Similarly, with respect to video, automatic video description, video classification and labeling, and action recognition, object recognition, metadata generation, and content moderation. So this type of AI models are available with respect to video. And document search synthesis, OCR and text. This is still one of the major area, I can say. OCR is going on for ever long research study as such, because the languages or different types of languages may not be available. Let us see this. Maybe Vertex AI can give a good fine-tuned model for us to understand the different type of OCR language specific OCR also. And information processing and archiving, and validate and enrich parsed data, and integrate human in the loop document review. That means even human can give the feedback in the interaction with the documents. That's what it is. With respect to the speech, again, it is automatic speech recognition across 140 plus languages, audio transcription, video captioning, audio data insight extraction, text to speech, including 200 plus voice options, and custom voice also. You can give your own voice also. Apart from that, even tabular forms like Excel sheets, if you have, on the Excel sheets, what type of exploratory analysis you can do it by making the graphs. All these things also available. Due to lack of space, I have concised. So model customization is highly feasible in Vertex AI, so that we can deploy, we can model tuned, and evaluation tools are also available, and we can see the performance of the model, how it is being doing. And MLOps, machine learning operations workflow was readily available, which can be utilized in like production ready solutions in that, and you can deploy it to the endpoint and access the external information like other than the Google. Let us consider inside it is not there, somewhere external the information is available, you had to extract from that and you had to bring that also is highly feasible. So the multiple ways of accessing the external APIs in real-time information and get the real-time information, that was one of the wonderful provision has been provided in Vertex AI. So on ground reality, it will search for the source of the truth, and it will own, and it will grab that by using web search and help and reduce the hallucinations here. And RAG is one of the best technique, which will get the external knowledge resources, and it will maintain its own. Those external resources can be maintained in its own databases, and it will curate that, and it will give as a response to our queries as an information. So that is will be done by the RAG. We'll see one of the example I will show at the end of my talk. And functional calling, any real-time APIs are there. That means already REST APIs or something or URLs are available readily, which can be able to utilize it on real time. Still, the access is available. So citation check with credits to the source of the responses, it will give the response to. And responsible AI and responses I already explained to you. It is giving a safety for us before going to return. It will give a filter actually before entering into the Vertex AI generation models, and after getting response also, it will validate once again back to give the fallback response. So overall, this is the one main Vertex AI platform looks like this. For example, so you have a we will go from bottom to top so that we can understand what and all operations so you can able to do it in sequential in Vertex AI. So the first one is like the platform is like Google Cloud Platform that anyway we have, and it is enabled with the GPU and TPUs. So you need not that you don't have any depth of the infrastructure as such. If you want how many GPUs you want, how many TPUs you want, you can able to set on the Google Cloud so that that same thing can be utilized for your solution formation. Then top up of that, if you come to the Vertex AI Studio, you have a Vertex AI Studio. In that Vertex AI Studio, the basic one you have to select next one is a model, which type of models you have to use it. Garden. So as I said, there is a Google models are available, AI models are available. OSS means open source models are available. Then partner models. So go partnership with Google. So those models also will be visible to you. So on top of that, we have the AI platform where you can able to give the prompting, okay, extension connectors and tuning, distilling, evaluation. This is the monitoring, the AI platform, MLOps. We can say it is a MLOps pipeline, we can say. So in this operations, you can check how the model is performing and how to tune the models. You can able to check how you can compare the models, and you can distill the models, and you can evaluate it. So that can be done on the AI platform. And after doing this one, if you are developing an application like AI solutions, let us consider documentary or discovery, risk, healthcare, it is specific to some of the domains you are developing some AI solution. Okay, so you had to do either search or conversation. You had to search on the AI platform which you have been selected. So that's why here Vertex AI search we'll call it as Vertex AI search. Will search the models respect to that, and it will give the response to you. Similarly, conversation by using RAG only, they are also doing that. So the whole Vertex AI platform is available on your Gemini, on your Google Cloud or Workspace, Google Workspace like Jupyter. You can able to use it. And here foundation models, the partner models I have listed here, like A121 Labs, Anthropic, Cohere, Contextual.ai, Midjourney, Osmo, Resistant.ai, Meta, Runaway. These are all some of the partnering industries with Google. So their models also is available on the Google. And when coming to the modalities, how many types of modalities it is giving, what type of task I can do it in Vertex AI with what type of features and who is providing that one, if you see. And this is a glance of that, like modalities, language, vision, tabular, document, speech, video modality, and audio modality is available. So these are different types of modalities it is supporting. And the tasks are generation. Generation task means generating text, generating image, generating video, like that. That is not nothing but the generation. Similarly, classification models, when you come, it will classify the images, it will classify the audio, it will classify the text, like that. So like that, classification models, detection models, extraction, recognition, translation, embedding, segmentation, retrieval, open vocabulary detection, open vocabulary segmentation, tracking, radiology, forecasting, pathology, dermatology, automatic speech recognition. These are the few I'm saying. See, if you come to the dermatology and pathology, there is only one model, one task only is available. That means it is very domain specific, action oriented one. That's why. So features, if you see, we have Vertex AI Studio, API available, open source is there, notebooks are there, pipelines are there, and you can deploy in Google Cloud, and demo also available. And providers are, see, along with Google, we have other partners like Salesforce, Meta, the big prominent and sorry. So the big industry partners are available here, like Stability.ai, Minstrel AI, and Anthropic. So if you are using Vertex AI foundation models and you want to use Minstrel AI model, you need not go away from here. Okay, you can able to plug in the model from the Minstrel because they are partners. So that models also will be like that. And fine tune the models for your sake. So which will definitely it will improve as soon as even if you have very less number of samples you have, like 100 samples or something, then still the it will improve the model performance by using fine-tuned models. You can able to do it. And human feedback, definitely it will help you actually as a reinforcement learning to optimize the model performance. So this is the highly available here. And generate the model images customized to outreach the business actually. So object tuning, style tuning and all is available by using ImageGen. And improve Google's predictive AI. AutoML is available. So this will give automation layer for you as a pipeline so that it can predict your own data very perfectly. So the high quality models are available too in the Vertex AI. So the key features are unified workflow, predefined models are available, custom model tuning you can do, future stories there, and model monitoring can be done. And what are the core components you can use as is AutoML is there. So you need not write any code of ML. Just you have to give the link of the model, then the model will be, you can able to use as is. Notebooks are available so that you can write the code, you can customize your own code that you can write. Feature store, you can able to, features can be extracted from the data. You can store, save, and share also, and reuse the same thing also. Pipelines, you can automate the workflow of that and by the orchestration of the platform. And model deployment, you can, the models, once it has been tuned and you have feel it is good, then you can able to manage those models with our endpoints so that this can be utilized for other applications also. So batch and online predictions also available. That means on the fly, real-time prediction also can happen, or a batch you can provide in a set, and that also can be predicted and given to you. So such type of prediction services are also available. These are all core components of your Vertex AI Studio platform. Now this will give, with this information, I think you can understand this picture very well. Because a developer will start with notebooks, right? Where he will write the code and he can use it the pipeline as such, right? A pipeline can be able to create. So where the data source will come, which model they have to use, how he has to evaluate, what are different types of models he has to use, how can he compare or distill, or we can, so such type of pipeline he can able to use it. So where he can able to monitor the model with explainable AI, you can able to check which features are literally relevant to that actually the prediction of the model or any service of the models, and future store or futures saving that one. and metadata also will be saved. So this is very highly, which is lagging in our own creating our own AI models at our on-premise, and which having the pipeline at the Google Cloud. So this is one of the best thing. So you can experiment, you can train, and you can deploy the AI models over there. So AutoML is having all types of modalities of models are available, AutoML. So no code and no code workflow for this. You can customize the training totally, and you can able to optimize it, the models also. So you can, one of the thing, the MLOps system, what it will do is, it will merge the data set, different data sets can able to merge it, and it will fuse AutoML models, and you can deploy on the fly. It is like home delivery for us, right? Nowadays, we are not going to cook each and every part at our home. Whenever you feel hungry, how can you are you are ordering yourself the recipe which you want it, the food you want it, and it is come delivery on you. So similarly, when you want to build applications on the AI and ML and the generative AI, Google Cloud is the best platform, I can say. With a little amount paid, you can able to use it as is. So the benefits is end-to-end ML workflows are available. So for experimentation and for user satisfaction and for customer satisfaction and faster building the applications, this is definitely, it will help you a lot. Pre-built, because of pre-built tools are available, cost efficient with the manager services. The same infrastructure we cannot able to maintain, so we can able to afford this one as a cloud infrastructure. We can use it, and enhances the collaboration with versioning and reproducibility. So now I will tell you the next part of that one. That means till now we are using the LLMs like that, no? Is there any other way? Like instead of one task, can you do different tasks at same time? Like parallelism, parallel task. We used to manage the same way, right? Usually how we will do is, when you are performing some task, no? If some other task has to be linked over there, parallelly it has to be executed, definitely we need to, that also to be in the pipeline. So what happens is, the pipeline should not be in a single sequential layer as such. So the pipeline can be able to divide into parallel processes also. So for that sake, here the AI agent will help you. So the agents will do one task of that. So it will harness the large LLM models actually to get into one desired output. I'll give one small example for you. Let us consider you want to go for a trip. Now Kumbh Mela is going on, so I'll take an example of Kumbh Mela. So I want to go Kumbh Mela in the third week or a fourth third week is the last, I think so. Okay, in the third week of February, I will give only this much. Now what happens is, the task of that the NLP can able to understand it, right? The prompt will divide it into different multiple tasks of that. What and all it should do? First, it should check on the third week. Okay, which dates it has to fix it, because according to the travel schedule and flight availability, accommodation availability, and facilitations at that Kumbh Mela availability, it has to coordinate each and every other activities, and it should come. So for that, what happens is, for each and every activity, one AI agent will work off that. So one AI agent will create the schedule. Another AI agent will find it out according to the schedule, what and all accommodation, how to book it, how to book the train tickets, okay, or any other connectivity, transportation, okay. So any facilitations further of that, and suggesting which are the places it has to be visited by another agent. So like that, multiple agents will work together. That is autonomous AI agents, which can able to work together to a desired output or goal. That is nothing but generative AI. So for this, we have some popular agent AI frameworks are available to orchestrate this multiple agent workflow. So what are they means? I just few I have kept it here. Q2 AI. So which will play a bigger role in AI agents orchestration. And Langflow is a low code AI builder, which is based on agentic and RAG apps. Okay, so wherever the augmentation response has to come, okay, so their Langflow will be used, and LangChain also, because Langflow will inbuilt, actually LangChain will be used, and LangGraph is there. So where the same flow will be available in a graphical way. So it builds a stateful actually. So it will totally identify the flow of the statefulness of the activity. So multi-actor applications will be there with LLMs. and also it create an agent for each and everything for multi-agent workflows. And feed data is there, which will be more, it will be memory will be there, knowledge will be there, the tools and reasoning will be available in the feed data for the multi-data. So all are working for multi-agent platforms itself, multi-agent frameworks, we can say. So what are the key components of that? So there is an agent architecture will be there. Okay, how the memory systems decision making should happen, how the interactions between the agent should happen. So that architecture should be there. And what are the environment phases? Which operating environments it has to interact, and what is the simulation of that? Task management, how to define it, how to assign it, how to track the completion of the task. Communication protocols, because the communication protocols here plays a major role, because of less latency, they can able to interact and take a decision properly. So communication protocols is having a high impact on that. And learning mechanisms. So ML algorithms has to learn from the agents and improve the performance over time. And integration tools will be there. So where different data sources, because when flight booking means you have to interact with the flight data set, right? And when you go for the accommodation, it should go for the booking. So different hotel bookings and the transportation is different. So different data sources, different APIs, and it should be interact with different software systems also. So that also it has to do. Then monitoring and debugging will be agent behavior, because how the agent is behaving, how is the performance of the track. So what are the issues it is facing? So such type of things also can be able to track here. So that is what it is, the key components of AI agent frameworks. So the AI infrastructure recently, NVIDIA Blackwell GPUs for training and inference engine has bring it, so that it will support this type of inferencing computing engines. And it was enabled with the GPU. What is highly required is GPUs are required, okay, for a good latency, and as well as PaaS. This platform as a service also is highly required, and inference engines also is to be required. So all these three coordinately required for the infrastructure for autogen generative AI. So right now, that's why the LLMs and LVMs are training on trillions of parameters to understand a large data, to understand of that. Now, what is the last one I want to tell is, it is not only on the software base, now they are spreading across to the devices level, where the IoT devices, for example, the edge devices, it may be mobile, it may be any other sensor devices, IoT devices also it is reaching. Okay, so NVIDIA means the agents can run at the smaller scale AI models at the sensor level also. That's what I want to tell you. So NVIDIA has been given a developer kit, Jetson Orion Nano Super Development Kit for this type of edge devices support. So just this for information actually. So it is spreading across, so that now any problem statement, any research problem also you are targeting for a particular domain, you can use this type of agents. Okay. And lamps. I'll just give one small introduction about it, because I think another 5-10 minutes is available. Okay. So lamps are nothing but large action models. Till now, people are thinking only LLMs itself. So the next trending is going on with lamps, where what happens is here actions into coming into the picture, into the environment. So it's not only for information based or generating something, and it will perform the action also at the back end. So that is a given environment, whatever system you have. So that lamps will be having the foundation models here also. So real-time adaptation will be there, because on real-time, on flight should do it. Data-driven training and neuro-symbolic integration is there. The key characteristics is like goal-oriented, contextual understanding, and action-oriented. Here, the main difference is it is an action-oriented. It has to perform some action and it has to do the generation. So that is it. So transforming data into action, that is what it is a major role. So it identify the opportunities, and it will suggest the strategies of that, and it is implement the actions. So pinpointing the insights, what it is, recommending the specific actions, and personalize the task for execution of the implementation. So transforming industries now at current day in everyday life is like automating tasks like personal assistance, robotics, workflow automation, and enhancing the decision making also, like data analysis and insights, personal recommendations. It has to enhance the decision making of that, and creative interactive experiences, gaming and entertainment, and personalized learning. I think the next speaker can speak about the immersive technologies. Maybe this is one of the way the lamps can help actually the generative AI models. Here, lamps can help in the gaming and environment, so that on the flight can create it can create instant what it is game actors also as such, because depend upon the decision it can create an actors. It's not like predefined gaming environment as such. So that is also feasible here. So the promising applications here already introduced into the industry is rabbit, AI powered game characters, and intelligent process automation. So these are available. So this is the difference between the core technologies between LAMPs and LLMs. So LLMs are transformer architecture, and LAMPs are reinforcement learning architecture, and LLMs are training methods, and LAMPs are real-time data processing, and LLMs are mostly on NLP, and here action prediction and recognition too, LAMPs. Okay. So the challenges. So here also some challenges. Every technology is having the pros and cons. So what are the challenges of LAMs is ethical considerations. So that's why ethical AI also has become very good prominence at the current industry, because potential bias should not be there, employment problem is there, and human autonomy is there. So this is one of the ethical considerations with respect to challenges of LAMs. And safety and reliability. But by mistake you have done it, but you cannot be able to take back by the time it could have been executed also. Okay, so safety, as suppose if it is not safer, a parent has to do the booking. Actually, by chance, if child could have been triggered, that it could have booked. Correct, right? So it should be very preventive harmful actions you can able to prevent. You had to think about the safety and reliability of the systems for implementation, and explainability and transparency. Why the decision making is by the LAMs are perfect actually. So at each and every decision making in the from the AI agents or from the action oriented with the environment, real time environment, you have to see that whether the decision making is uh, correct or not, and accountability also should be there. Okay, depend upon that only it should be accepted the solution, or else it should be rejected. So this is what my till now I have been told. And very simple 1-2 minutes I will take what we have done in a CDAC actually. So okay, so I will close my talk also, delivering the talk. So LLMs we have created here for conversational chatbot, especially for the domain of mental health, mental wellness app, and where we have created multi-agent collaborative workflow. So it will dynamically retrieve the information. Okay, there are two type of sources here. One is we have internal our own data is there, and apart from that, I want data from even from internet also. So it is having the my multi-agent workflow will work on two different things. One to retrieve the information from our local data set, and another from external internet also. So with that, we have created an LLM and we have implemented. So we have collected data collected from different types of journals with respect to mental health, with the different journals like Culture, Mental Health, PubMed, Asian Journal, Psychiatry, like that. Very prominent international journals we have taken. We have collected from the internet and we have created our own database for that. And pre-processing, we have done it by using data extraction, and data cleaning, we have done it for non-ASCII values and all. And in that, if it is papers are having any table structure, it will be converted that into HTML by using the fine-tuned models YOLO-X. And later, sorry, and data indexing we have done. We have followed the hybrid method. One is a sparse indexing, another one is a dense vector indexing. So any data we have to make it into the vector models, vector database. So vector database also has been indexed into two parts, and we have followed the hybrid approach, so that the ranking of the documents, retrieval of the documents will be having a more relevant documents and high accuracy because of that. So multi-agent collaborative workflow, we have done it. So any query, the BQ is nothing but a query. So that query, if it is passed, compute the embeddings, vector embeddings from the STS, and compute embeddings in the keyword search. So vector store will be there, and BF25 store will be there. So where the documents will be retrieved and it will be applied to the BQ. And if the aggregator is giving the generating result which is accurate, it will generate the answer, or it will be discarded. If it is not relevant document, it will be discarded at this point. So this is the search engine capability for parsing mental health queries we have been built, both for in-house and out-house data. And this is the retrieval augmented generation model has been developed by using LangChain for powering the question answer system actually. So as you see here, the query will be submitted and combined the prompt engineer prompt will be there. which will find it out the relevant context, whether it is related to mental health or not. If it is related to mental health, it will pass to the LLM and then we'll get the response and get it. And here embedding models we have created where the query embedding will be saved into our own vector storage, and relevant context will be able to prompt as an input to the prompter so that it will able to access to the LLMs. So this is what implementation. If you give one initial query here, it decomposed into different types of queries. Like LLM, what is LLM? Only we have asked. So this is what is LLM, and it will give with respect to the resources. It will explain what it is. So different types of forms of the same type of query will be retrieved from different sources. So some are from in-house collected data, and the others are from the internet. So on mental health app, we have created an interface to ask. So we call it as Asha. The chatbot, we called it as an Asha. So Asha will be interacting with my conversational AI at the backend, and it will tell about mental health queries you can able to ask, and it will give a reply to you. So this is what implemented at CDAC. So I would like to conclude with here. So we have just in general, we have learned, I just gave some introduction and some insights into general AI and importance, how it is important for us, and how Google is giving major role, playing a major role in providing the cloud platform and the Vertex AI studio for benefit of the people, and how AutoGen Gen AI will help us, and what are LAMPs, large action models, how to make use of that for our problem solving applications. So with that, I would like to conclude my talk. Thank you so much. And I will hand over to you, and you can ask some if you have any questions. I might have. Shall I stop sharing? Hello.
Dear participants, if you have any queries, please feel free to ask.
Good evening, madam.
Good evening, sir.
Madam, actually, you are given a list of the steps which are implemented at CDAC Bangalore by using LLMs. Can you share that slide, madam? That implementation steps.
Yes, sir. Is this the one?
Yes, madam. This one only, madam. This one. The data which you are collected, is it you are connected with any Kaggle database or?
No. That's why I told her. We have collected resources from international journals. Okay. Culture, mental health, PubMed, not with the Kaggle, sir. Kaggle won't have the data.
But this anyhow, this being it is a machine learning process, it's need most huge data, right?
Yes.
Then how much length of data you may be concentrated, madam?
Sir, we have collected as such because we have a Param Utkarsh supercomputer on in-house here. So we collected and we have trained on our own infrastructure, sir, actually.
So that the infrastructure which you may be called any other name, madam, or?
No, sir, it's our own supercomputer where the models can be created.
Oh, right. So if you suppose we want to concentrate, it's not possible then, though we have not in terms of high computing interface devices which we are using, right?
Yes, sir. Maybe this is very specific domain too we want to build for mental health. Okay. So that's why I'm saying we are thinking, see, the first breaking point for any researcher or a professor is they will think the first infrastructure, I don't have this type of data. The first is data source. Second one is they will tell the infrastructure. And the third one is platform for implementation. Am I right, sir? So these are the major barriers actually. Barriers for any researcher. So what I suggest is the Google Vertex AI will give the entire platform for you. Okay, but data it will not put. We had to we had to parse up data actually that has to be done. Okay, so data sources are most important. Okay, if it is a generic, people used to go for web scraping and then bring the data and they are doing. Okay, with the Kaggle data for small projects it will help, but not like a realistic applications to use in daily life. It will not be helpful that much, sir, with the Kaggle data. Okay, so better, my suggestion is you can go for web scraping, or if you have any domain related domain experts are there, you can create yourself for huge data. Or web scraping is one of the best methodology for creating the data source. Data sources.
Thank you, madam. Thank you. Actually, we are concentrating on cognitive process for psychometric data sets.
Okay.
So, of course, though we have a little bit data, so of course, your steps may be useful to us. Thank you so much, madam.
Okay. Thank you, sir.
Good evening, madam.
Hello.
Hello.
Yes, sir.
Madam, I have one doubt. I have script, Kannada script of 200 years old. I need to convert the script into English. Is it any model is available for converting the scripts,
Okay. So it is like a image to text. Am I
madam?
right, sir? Or it is text to text? Is it image to text or text to
Uh,
text?
Image to text, image to text.
Sir, what I will, my suggestion is you can use some pre-trained models, sir, for image to text like image gen, like that. Okay. If it is not detected, you have to give some data set of your, because Hale Kannada means may not be trained by Google or open source pre-trained models as such. Correct, right? That is what the lagging was. So what we had to do is at least some few data sets we had to create on the fly, the transcription of that image, I mean. Okay, so after creating you can able to augment that, so it will create similar type of text so that the models can able to understand easily. So pre-trained models also will help you, sir, actually to do this.
Thank you, madam.
Yes, sir.
Madam, if possible, can you share your email ID, madam? If we suppose we have any doubts, we'll mail you.
Yeah, sir, definitely, sir. We are working in Canada also. Okay, and I'm working in Indian language and heritage computing. So for our heritage also we are supporting actually, because we are from CDAC, right, government, right? So like us people only should support. So that's why feel free to interact with me. This is my mail ID. Okay, I'm just sending in the chat. Okay, this is CDAC mail ID. You can connect with me, and you can ask any doubts or any suggestions and any collaborations you would like to have. Everything is open to you. We are for you. Okay.
Thank you so much, madam.
Thank you, sir.
I think no more questions from the participants. Okay. On behalf of everyone, I sincerely thank Dr. Sarita for an insightful session on the generative AI. Your expertise on Google Vertex, AI, and model fine-tuning has deepened our understanding of its impact on AI. We appreciate your time and insights and look forward to applying all these in our day-to-day work. Thank you, Sarita.
Thank you, Dr. Sunita. Thank you for giving this opportunity, even to interact with the faculty people and researchers also. It's a wonderful session for me. I too enjoyed by giving this, delivering the talk.
Thank you once
Thank
again. In a couple of minutes, we are going to start the next session. All participants, I request you all to please switch on your video for a group photo. All participants, please switch on your video. Thank you all. In a couple of minutes, we are going to start the next session. Thank you very much, Sarita, once again.
Welcome.
Good evening once again. It is my honor and privilege to introduce an extraordinary academician and leader, Dr. Satyanarayana Nanduri, who has made profound contributions to research, innovation, and education. Dr. Nanduri holds a PhD in Computer Science and Engineering from IIT Kharagpur and an MBA from XLRI Jamshedpur. He is currently the Director of R&D at Geetham University. Dr. Nanduri served as a professor at ACSIR University for nearly 11 years and significantly contributed to his foundation by drafting policy guidelines, structuring the university, and preparing the ACSIR University Bill, which is presented in the Parliament in the year 2011. He later established the ACSIR campus at CSIR IICT and served as its founder coordinator for about 8 years. He was also actively involved in mentoring and fostering the innovation, serving as a secretary of the Biotechnology Incubation Center for over 10 years, that is during from 2010 to 2020, and nurturing the startups and incubators for over 14 years. Dr. Nanduri has led R&D projects worth over 60 crores in process simulation, material characterization, and energy and environment, along with 325 crore in process engineering, healthcare, and materials. His research has earned 5 Best Paper Awards, and he has supervised 4 PhD theses and 28 PG dissertations. At CSIR NML, he set up a supercomputer facility for process simulation and modeling, developing real-time simulators for metallurgical reactors like blast and submerged arc furnaces, which were successfully implemented in Tata Steel Jamshedpur, Bokaro Steel Plant Rukarla, Now Bharat Ventures Angul, and Tata Steel FAP Balasur. At CSIR IICT, he established the Department of Energy and Environment in the year 2017, leading projects in clean coal and waste valorization technologies. Under his leadership, DEE contributed 30 to 35% of CSIR IICT's industry revenue. He also mentored the Business Development Group from 2017 to 2021, formulating strategies that double the institute's industry earnings within 3 years. Dr. Nanduri's group developed the portable automated ball indentation device at CSIR NML, which won the Dr. Altekar Best Technology Award in the year 2009. In 2021, his team at CSIR IICT received the CSIR Best Technology Award for their anaerobic gas lift reactor for biomethanation of organic waste. He has been a key figure in national committees, serving as chairman, member of DST Inspire, DST Kiran, Nano Mission, Ministry of Electronics and IT, CII, MSME DI, NIRF ranking for R&D institutes, and many more. His contributions include the preparation of several technical reports and white papers for these committees. Dr. Nandu's current research area includes wireless sensor networks, IoT and big data analytics, smart cities, process simulation and modeling, sustainable technologies for energy and environment. With such an illustrious career spanning research, academia and innovation, it is truly an honor to have Dr. Satyanarayana Nanduri with us. Sir, we are privileged to hear from you. Over to you, sir.
Thank you, Professor Sunita, for bringing me onto the platform. I see that, there are close to about 200 participants, almost, the fag end of the day. But then I was, also listening to what Dr. Sarita had to deliver. And I was also very much impressed with the level of participation and involvement of all these 200 plus participants in the deliberations, and also the type of queries they have raised. So I'm not sure whether this interest will sustain for another 1.5 hours. So in fact, Dr. Sarita made my life a little easier, because I now no longer need to talk more about the Google Vertex AI, because one of my the earlier PPTs, in fact, I made an elaborate preparation on how to write the code, how to do the prompts and all, and then in different versions, be it Python or be it any other languages. Okay, so those things I will skip, and then try to make this session a little more in a lighter way, without much technical sounding, especially because it is the fag end of the day, and I know that I'll be I'm in between you and the dinner, which always is very exciting when you are at home, and then would like to share it with your near and dear ones. Okay. So with this, let me, put up my slide. Kindly let me know if you're able to see it. Yeah, is it visible?
Sir. Yes, sir.
Full screen? Yeah, is my screen visible?
Yes, sir, it is visible.
Yeah, okay. So what I would be trying to do is, take you into the experience that I had in trying to make, the process simulators for various reactors, primarily, metallurgical reactors and later chemical reactors, and also, in the power sector. So unfortunately, when I started working on those process modeling and simulation trials, I did not have, Google Vertex. So I was handicapped in a way that, I was not able to bring in the type of immersive environment that would have been, so much pleasing to explain, what the model would do and what the model would predict. So with this, let me, give you a brief of the what I would be covering. First, let's try to look at, understand what is immersive environment, the applications and challenges, and then what is it that, the Google Cloud Unified AI platform can do for helping us with designing, the immersive environments. And then per se, how the Vertex AI for immersive environment would do. I will also cover, some of the case studies, the challenges, and the technical considerations. So these case studies, let me confess, are something which I have not really tried to look at Vertex AI and then try to generate them. But these case studies are the ones that I have simulated maybe about 15-20 years back, when people were not even talking about cloud. So if I had an opportunity now, what is it, that I would be doing with the type of process simulation models that I have developed about 20 years back? That is what, I'd be covering. Now, looking at, trying to understand what is immersive environment, of course, it's an immersive environment is creates, a virtual or an artificial environment. And what basically it does is it will take you into a system where, virtually you see everything around you. You can also hear. Presently, you do not have, the fragrance or, smell coming out of the immersive environment that is being created. All you have is, audio visual. But then very soon, maybe you'll also have an environment where, supposing if you're walking in a garden, you'll also be able to, feel or, smell the type of, the fragrance that is coming out of the flowers. So that would also be coming out very soon. And generally, for any immersive environment, you need, a few media or mechanisms by which, you try to immerse yourself into a virtual reality. So one is, the virtual reality where, you have a headphone which you wear, and then you have this a feeling that, you're immersed into a real world where you are exploring, some of the wonders of the world, or, you are going into a manufacturing section and then trying to go into a furnace, a reactor, and then trying to understand what it is showing. Okay. Or, it could be an augmented reality where, with the help of your own, a laptop or, your smart sensor, so smartphone, you'll be able to see, or, try to identify what you are seeing in front of you, even if you do not know anything about, what you are actually seeing around. Just by capturing an image with the augmented reality, you'll know, where you are. Similarly, when it comes to mixed reality, it is a mix of both virtual and augmented, where it's primarily used for manufacturing industries. And then, of course, we have, experiment on digital twins. I'll try to briefly, give an overview of all these different media in the next few slides. Okay. Yeah, once you have this virtual reality, I think you will always feel that whether you are wherever you are placed, you will feel at home. Okay, so that's the type of ambience that the headphone, the head device that you have gives you when you are looking into virtual reality world. Okay, so this virtual reality is a audiovisual simulation of the real world, and all the users they experience this environment through a headset. So they have a headset through which they have this immersive environment. Okay. Now, one thing is having a 2D framework in front of you, but then if you really need to have a perception of depth, as you all know, you need to have two sources by which you are two images that you capture. For those who are blinded in one eye, they will not be able to have a perception of the depth. So you need two eyes to look at the perception of depth. So to create that, the VR headsets, what they do is they create spatially separated video in each eye. So that will actually give you the perception of depth. Okay? Now, one thing is, just having, a screen in front of you and then trying to find to see that, you are going through. But then you also have, some motion sensors that are embedded, which act as, tracking systems, and they actually present a sense of a movement in an immersive environment. Supposing, you have a devised, environment where you are going on a roller coaster. Okay, you are having a roller coaster ride. Apart from, seeing what is in front of you, you will also be able to visualize or, feel that you're actually going up or going down a roller coaster. You'll also find the vibration and other things that is there, that you'll be experiencing. So in a way, without actually going onto a roller coaster drive, once you have this headset device and all these motion sensors embedded into the environment, then you will feel as if you are actually going up and down a roller coaster. Okay. And for that, VR uses visual, auditory, and sometimes a haptic device, so that you'll also have a feel of a touch, or a sense that, or you're actually holding on to something. So all these devices would be there, whether it is a visual, auditory, or haptic devices. So that in a way creates the holistic experience or realistic experience when you are looking at virtual reality. The next is, the augmented reality. So in augmented reality, what happens is you have these devices. I think most of you are familiar with the Google Maps, right? So in Google Maps, when you fix a destination and then start moving, you'll find that the position is marked, and then arrows are there, and then you always feel that you are actually moving. You know where you are moving. So this augmented reality is the one which overlays the digital information, like 3D images, videos, models, real world, and enhancing the perception of reality. So you really know, where you are going. And and many times, what happens is you can also have these things on the mobile app, like someone, who's familiar with Amazon, and you want to buy a curtain for your windows. The Amazon app gives you a small clip where, it will ask you, you take a picture of the window where you want to keep this curtain. Okay. And once you do that, the app will actually create the scenario where you're actually seeing a curtain adorned with a curtain that is adorns the window. Okay. And another example is, you have these navigational aids, and then lens cut also, it gives you an experience where, you can try different sets of frames when you're actually looking at. So I just, captured, few images of myself on a lens cut image. So when I was trying to, look at, 3 different frames, you can see there. Okay. So all it does is it will first capture your image. Okay. Once it has captured your image, then it will superimpose or overlay the different frames, so that you have an idea how you look when you have wearing these different frames. Okay. The first one is a golden frame, the second one is a dark frame, and the third one is a blue half frame so you can try on any of these devices or any of these frames, and then you will have an idea of an augmented reality sort of an environment where you will really know what you are looking at. So similarly, another thing is, the mixed reality, where, it is a immersive computer generated environment. Okay. And with this is primarily used as an educational tool, or it can also be used as a device where you will be able to understand what are the processes that are happening in if you are looking at if you're able to generate it for a process simulation industry. I have a few case studies where I'll talk about the environment that can be created when you're looking at a blast furnace, iron making blast furnace, or maybe submerged arc furnace, which makes ferroalloys. Okay. So here, in this mixed reality, what happens is the user interact with and manipulate the physical and virtual items in the environment. So what would happen is, if you are actually looking at the human anatomy, like this lady doctor is doing, maybe she can make some changes there, and then see what would be the response of the other nervous systems, that she's actually experimenting with the nervous systems there. So maybe if you can cut off one of these nervous systems, she'll be able to experience what would happen. So this actually works as a very good tool to understand and an experiment without really looking at physically doing the experiments, and it becomes a wonderful tool for understanding any environment. Okay. Coming from the background of creating modeling and simulation studies for several reactors, this would help students like me to understand what would happen if the temperature in particular area increases. What would happen if the electrode position changes. So all these things, I will be able to track and then put them in this mixed reality environment where, it becomes a good tool to understand what to do and at the same time what not to do. Okay? So one of the examples that I've shown here is the surgeons can have a hands-free access to vital information. So they really need not cut open a body to find out, what information they need to get. So this becomes a wonderful tool for the student, for the surgeons to understand the human anatomy without really cutting as open as a body and then trying to see what it inside it. Okay. The next is, the digital twins, where, it is a way to create virtual models of physical objects, processes, or systems. Okay. Now, what happens is these models, they use real-time data to simulate how the real-world object behaves. So here, I gave an example of an AI-generated picture of a blast furnace, because this is where, I've extensively worked. Okay. So if all your sensors are connected to this blast furnace, then whatever is happening inside this blast furnace, what the temperatures at different sections of this blast furnace, you will be able to see through this digital twin. So it is, in fact, earlier, we used to call it, mimic diagrams when I was, making them maybe about 15, 20 years back. So we used to call it, mimic diagrams, and with the limited graphics that we had, whatever we created, it was looking, something out of the world. But then if I look at the type of images that I created about 15, 20 years back, they would look very, very primitive, because we did not have the means to, create the type of graphics that present generation would do with the help of, this AI generated images. Okay. So while modeling it, what we have done is in the blast furnace, we had several sensors that we have kept, and each of these sensors would give us, some signal how the process is behaving in the blast furnace. Okay, so in digital twins, what happens is you have exactly a replica of the process that is there. So that's the reason it is called a digital twin. Okay, and then what you actually do is you collect a lot of data, and this data will help you, the modeling. And of course, for data collection, you need to have sensors. That's what I mentioned on the physical object that collect real-time data. And this data would in turn help you create a virtual model. Okay? And this will also help you in simulation and analysis, because once this virtual model is used, and then you are able to simulate how the object behaves. So this behavioral pattern would actually help you analyze the object. That is, by looking at different we call, in statistical terms, it is called, sensitivity analysis. So when you call sensitive analysis, what happens is you have a set of parameters, okay, maybe about 10 to 12 parameters. You vary one of those parameters and see how it affects the other parameters. So that is how, you try to look at the sensitivity analysis. So this helps us, if you have sensors hooked on to the industry, to the reactors, you'll be able to know the behavior, and this behavior will help you analyze the project. Okay. So this is an example for this, process simulation of metallurgical process, which I'll cover, maybe in the case studies. I'll try to elaborate, what can be done, make use of the simulation models for a metallurgical process. Okay. Next is, let us look at, what are the applications and the challenges. By the way, let this be an interactive session. If anyone wants, you can always, stop me at some point, and then there can be questions. I'm always happy, to attend to the questions, because that's where, more learning would happen the moment you ask questions. Okay. Now, if you're looking at, the applications mainly powering the future of immersive experiments, gaming is. Yeah.
Sir, actually, you are defined that immersive as per a definition and created such a process simulation. Is there any the platform which you can interact automatically parameter to parameter, sir? Is this completely software based or
Yeah, it is software based, but then like any other AI tool, it would require data, right? Okay. So once you are able to feed with data and then try to feed in several schematics of the reactor, then the AI would actually learn and then come out with some stunning visuals which will be very very appealing. Okay. So did I answer your question?
yeah? Thank you.
Yeah. Okay. Others also please feel free to interject. Okay. Yeah. So when you're looking at these expensive immersive experiences, gaming is something which has a lot of scope. And if someone of you would like to turn into entrepreneurs, look at gaming as one of the tools where you can do, and you do not require much of investment in that. You all need to have is a few tools, and then with the amount of money that is being spent in Bollywood, Tollywood, and Collywood and others, I think you'll be making able to make big money in this. Okay, and very soon I think the education industry would also undergo a lot of transformation, where all these gaming tools would be required to understand a phenomenon. So that brings us to the training and education. Let me tell you, I'll give you a personal example. I know a friend of my friend's nephew who was doing, electrical engineering at NIT Jamshedpur, because I was working at Jamshedpur for about 20 years. So I know him very, very well. So this fellow was, a mediocre student, but then a lot of intelligence and intellect. So soon after completing his BTech in electrical engineering, he did some odd jobs. He did not like anything. He just resigned. Okay, and then started, some video games and other things. And slowly he went into that field. And if those who have seen, movies like Robo and all, he was one of the persons who has made many of the graphics for that. Okay, so but there's plenty of scope there, and he's making good money there. He has also got several awards. So any entrepreneur who would like to look into this, gaming is one thing, training and education is another thing, where you have a lot of scope to make big money. Okay. And if you are a developer, if you are into this developer into the area of making investor environment, you also need to have keep on board some doctor with you, if you're especially when you're making something with healthcare. Okay, have them with you and then try to simulate, or try to make VR or AR or MR applications for different parts of the body. So that will help in healthcare, and also the doctors would be very happy to have your products. Okay. Similarly, manufacturing is one thing. Retail is one thing. I just spoke about virtual try-ons, where Lenskart is one example that I've given. I've also given you example of the Amazons, where you can virtually keep any product that you want to buy, place it at any place in your room. Okay, and then try to see visualize how it actually looks. And of course, real estate is also one area where people have been using. You will find, a very wonderful graphics when they say that, this is what, we are making a clubhouse or something, but then the reality may be something different when you actually land up at that place. It might look totally different from what it is shown in the by through the graphics, these people, try to lure you. Okay. Now, let's look at some of these challenges when it comes to, the immersive environments. The first, of course, is the cost and pricing issues. This is taken from a reference. I think I've quoted it here. You can look into for the full paper on that. This is not my work, but then I like this, so I've just put this here. Okay. But in addition to this, there are other challenges which I try to cover. Okay. the cost and pricing issues. For like this is for any technology that you have, whether it is not necessarily for immersive technologies. For any technology, you need to have this cost and pricing issues are there. The security and privacy issues, because you should be careful that whatever device or whatever technology that you make, it should not fall into the other eyes. It's not happen that if this headset is worn by anyone else, it starts streaming the images which are not intended for them. Okay, and then this also brings us to the usability issues, the design issues, technical issues, and others. Okay. But to me, what is more important is the computational power. Okay, because once you are actually trying to have a high demand rendering and processing, you need to have enormous amount of computational power. Okay, about 20 years back, when I was heading the supercomputer facility for making a process simulation lab. Okay, we had the top end Padma 10,000, the top end supercomputer at our disposal. Okay, so with that, we were able to create a lot of modeling studies. Okay, but then now, if I look at the computational power that even a small workstation would have, I think I would really trade anytime the Param 10,000 with the present day advanced workstations. Okay, but then they require enormous amount of computational power. Okay? And there's a lot of data requirements that are there. The Param 10,000 that we used, and then when we are feeding it with data from 1024 sensors on a real-time basis, the models that we are preparing, it would take about 3 to 4 days for us to come out with the actual findings, with the results. Okay, but with the present computational power that we have, I think we maybe the same data had I fed now, I think the results would be there maybe about maybe if not maybe 2 to 3 hours. But then at the same time, the data requirements are also increasing, because as I said that if you want to have a good simulated image, you need to feed it with large amount of data, a large amount of images, so that proper schematic would actually come out of it. Okay, and another thing is the latency could be one issue if your computational power is poor, and then the data is that you have is very large, because by the time the data is captured and then it is converted into a virtual reality environment, there could be some latency. Okay, so that is an issue which you need to look into. And this we talked about for content creation. You need to have large number of 3D models and environments. But then the good thing is, if you initially feed it with about 10 to 20 models of 3D models, okay, which you physically make and then feed it, at every iteration, the Google Vertex or making the studio would be able to generate some more data, some more 3D models, and all these things now you can keep on feeding it iteratively, so that you generate a lot of models, and that will be the model will be learning from the data that the models that you tick and then say these are the correct models. They may also be giving out some models which are not accurate, but then if you are able to identify the accurate models and then say that identify them, then the content creation may not be a big challenge, because you will have in the AI generated 3D models which will be used as content generation. And then of course you need to have a integration where you have intelligent agents, object recognition, the understanding the scene. We'll try to elaborate these challenges a little more in the next few slides. Okay, so let's look at a brief overview of Google Cloud's unified AI platform and benefits. I'll not go much deep into it, because Dr. Sarita has must have covered all these things. In fact, as I said, I had few slides on how to go into the virtual studio, what type of commands that you need to have, what prompts you need to give. But then I have removed all those slides. because Dr. Sarita must have actually looked into it. So I'll not go into those things. But then look at what Google Cloud platform actually gives you. So it gives you an end-to-end machine learning platform, and it covers the entire life cycle. Okay, so when you look at the entire life cycle, the first thing is that you look into is ingest. Okay, so this is a phase where you need to collect a lot of data. Okay, and the data could be from different sensors, it could be from databases, it could be from logs, data logs, it could be from APS, and it could be files. So what actually is, if you are looking at purely talking in terms of the data analytics terminology, what you are having is unsupervised data, or supervised and unsupervised data, where you have data of different types of data coming. Some could be visual, some could be in terms of MP4, some could be in MP3 format, some could be just photographs, some could be some sketches. Okay, some could be some scribbling that you have in a record book. Okay, or different logs, maybe in the form of Excel sheets. Okay, some data coming from sensors. So different types of data that you need to have, but all these things you need to collect and then put them in a form which the user would ultimately be interested in. So all these things, fortunately, is done through the Google Cloud, and then through this ingest platform, to this unified platform. Okay. So once this data is there, the next thing is, you need to extract the things which are, very relevant to you, and then try to remove things which are not relevant to you. Okay. Because data is such a big data, especially we're talking of big data that is happening, that is all around. And also, when you talk of big data, you also need to talk about the 5 V's, the velocity, the veracity, the volume, and all other V's, that you have when you talk of big data. So from that, extracting the data which is actually really required is, a Herculean task. So this is where, the domain expertise matters. Okay, people will always script that once you have these AI tools, this will make the expert redundant, but then it is not the case. Okay, so because the expert is always required, because the expert is the one will be able to say that this data makes sense, this data doesn't make sense. So extraction is something which very important, very very important, and for this you really need to have a domain expertise. Okay, and once that is done, you should be able to visualize. This is again where you need to have the domain expertise. Okay, and then based on this you'll be able to learn. So that's what is analysis. So as an offshoot of slightly digressing from this, let me tell you, I've been on few committees where of DST and the Ministry of Information Technology, where we are evaluating some of the projects for funding. Okay, and I have been more or less ruthless in rejecting projects where you have only people from the computer engineering participating. Like, say for example, if you are saying that you want to make image analysis of all x-rays, take chest x-rays that are taken. Okay, and you do not have a medical expert in this, we have been rejecting such things, because I always believe that in addition to the computational talent that you have, you also need to have a domain expertise to say that this is correct, this is wrong, this is relevant, this is irrelevant. Okay, so whenever you try to apply for projects for funding, and if it is an application, it is a domain of maybe healthcare, agriculture, or business, or any other thing, maybe process simulation of reactors, please always try to take on board a domain expert. Okay, so let me tell you that when I was doing this process simulation of metallurgical reactors, I am not a metallurgist, so I always carried a metallurgist with me, who would actually guide me in telling that what data and what is the interpretation. So always keep this in mind whenever you want to make a project proposal. Always include domain expertise in your project. Okay, yeah. Okay. So once that is done, and then you perform this search and store from all the data that you have. Okay. Okay, and these learnings will be consolidated. So, and this is an iterative process. It's not that learning stops at one stage. So this learning iterative process, because the data collection is also iterative process, the analysis also keeps changing dynamically, and then finally whatever you search and store, that becomes a repository which from which you can always draw back and then further try to consolidate your learning. So this is where you will have those ANNs, DNNs, deep learning methods, which you'll be using it for proper learning. Okay. So there are certain things which I think you need to know. I have just put down some of these terms, which I think some of you would know, but then nevertheless, for to give a complete picture of what we are talking about, I thought these terms would be relevant. Okay. First thing is the vertex data labeling. Okay. So here you have a lot of data that you have. Okay. So there's a lot of data that you have. So what you need to do is you need to segregate this in the form of images on one side, text files one side, videos one side, some scribbling that you find in one side, and then so on. Okay. And then what you need to have is, you need to have a meaningful and informative label, so that, to retrieval, it becomes very easy for any ML model. So this is something that most of us neglect. We think that's a small job that doesn't merit, the attention. But then, yes, it is something, very, very important. It is something like, documenting your code. When you're actually initially starting to code, I think you feel that, documenting your code is something, which no one, which you don't relish. But then once you start, making some thousands of lines of code, you realize this importance. So similarly, vertex data labeling is something, which is very, very important. You need to label that. Okay. Next thing is, the vertex training. So what actually it is a managed service which allows, the users to train the models. Okay. And it includes, one thing is training. And then once you have the training, there could be, some finer points which are captured through some other means. So you need to tweak it a little, or tune it a little. So you need to have tools which help you for tuning or fine tuning, and also for deploying ML models. So fortunately, this Google Cloud's unified AI platform have the capability of doing all these things. And there's also the Vertex tool can also do a prediction. Okay, so it uses a service. This Google Cloud AI platform uses a service where the trained models through learning, they'll produce the predictions. Okay, and these predictions can be online, or it could be a batch production. I think you know the difference between online and a batch production. Okay. Just to tell you, online is something that you take real-time data, analyze it, and then make predictions what would happen in future. Second thing is, you have already data that has come through a batch, okay, which is presently not being used. It is static. So based on that batch, you say that okay, this would what happen. Okay, so where will actually help you? So when you're actually training, the batch prediction would actually help you, because when a batch prediction you're doing, you also know what are the inputs for that batch. Okay, and you'd also know what is the output that has happened through the log sheets that you have. So if your predictions match what has actually happened, then you can always validate your machine learning models. So these batch predictions become very, very important tool for validation. Okay, and then you also have this Vertex AI pipeline, where the users can build, they can manage and deploy the ML workflows, how it actually flows through. Okay, so this will help you. It's a serverless service residing on a cloud, and then you can use it to automate, to monitor, and then govern there what are the machine learning systems that you have. Now, to do all these things, what is very important for you is Vertex AI Workbench. And then I think most of you are familiar with Jupyter notebooks. So this similar notebook that you have there, where you actually try to come out the coding and then the prompts that you want to have and all those things. And then finally, you also have a model registry where it's a central repository where you can manage all through the life cycle of the ML. So all these things, are some of the important tools that the Google Unified AI platform presents with you. Okay. And these are some of the key features. I'll not spend much time on this. These things, again, I've taken it from Google. Once I Google, I got this. So these are the things, that you have. You can have a cloud storage. You have a feature store. You can do some experiments, pipelines, prediction, and all these things. Okay. So what are the benefits of using Vertex AI? Course, we did not have any other competitor for Vertex AI so far, but then now people are talking of the Chinese version of it. I don't know. I have not really looked into how it works, but then that could be a competitor for Vertex AI. And as you know, the Vertex AI, if you want to look at the total studio, you need to shell out good amount of money. Okay. But then I was told that this DeepSeek, the Chinese version, the money that is involved to make use of it is a fraction of the total money that is involved for making using Vertex AI. Okay, but leaving that aside, it is a scalability. Okay, in the sense that it can handle large databases. Okay, and complex models. It can do that. Okay, and then the speed at which because especially when we're talking of big data, velocity is something which we talk about when we talk of big data. So velocity is the rate at which the data keeps impinging on us. Enormous amount of data. Like say for example, if you are trying to monitor the traffic in a city, look at the amount of data that you get through the handheld devices that the people have, and then keep their location on. Okay, so the beauty of this is it can handle such speeds and help you accelerate the model development and deployment, and of course cost effectiveness. Uh, though I just said that to give the example of DeepSeek, the Chinese version, but then still all put together, all the things considered, and it's a cost-effective option because you really do not have to have a physical model to understand what is happening. Say for example, I go with the example of a surgeon. He did not really cut open a body to understand what is happening. So the cost effectiveness is one thing. Okay. And then the beauty of it is, you can always collaborate. This is what, I said, that, it facilitates teamwork because in a team with different domain expertise, all of you can come together and all of you will be working on the same shared resources. So all the combined wisdom of all of you would reflect in the in the outcome of the learning. Okay. And integration, of course, it can seamlessly integrate with any cloud services, Google Cloud services. Hopefully, it will also be able to do with any other cloud service, not necessarily Google Cloud services. And then it can always reduce the operational overhead. Okay. So let's look at the Vertex AA for immersive environment, along with the case studies.
Sir, can India also have its own open AI?
I think the NIC has some version of it. Maybe Dr. Sarita, if she is there, she would have articulated more on it. But then they have not become as powerful as the DeepSeek as the Chinese version. But then I just saw some news. I have not really verified it. But then the news is that Indian version has also come up, which could challenge the Google Cloud's unified platform in terms of the cost. Okay, I've just saw it in social media. I cannot verify the veracity of it. But then I just saw it in the social media just a couple of days back. Okay, but again, looking at the type of tools that we have, I don't see that it poses a big challenge now. I think some of you bright intellects can come together and then maybe replicate, what is being done by Google Vertex, and then maybe you can have now one version launched, a mini version launched. So the next few slides, we'll try to look at the challenges and technical considerations, where the case studies. Okay. So as we all know, understand that these immersive environments are transforming various industries. Okay? The lead that was taken was primarily in the petrochemical sector. So in the petrochemical sector, especially in the Gulf and other areas, where you have advanced rigging and crude extraction devices. So these things were already there, made much before this Google AI was in place. So, but then now these environments are transforming to other industries. Okay, but then all said and done, if you want to have these environments, you also need to have few challenges which I articulated in the previous slide. Okay, which are like high computational core demands, massive data requirements, real-time processing constraints, and need for sophisticated AI integration. Okay. So I was telling talking of few intellects coming together and then making an environment which maybe replicates the Vertex AI. So while you'll be able to succeed in making this, what you would also be requiring is high computational demands, which will require massive investments, which I do not know whether as individuals you'll be able to do. So there again, you need to fall back on maybe CDAC if you are looking at the Indian scenario, and then try to look at the computational, try to get and address those computational demand through the CDAC. Okay, but otherwise, I think all other areas, I think if a group of 3 or 4 people come together, you will be able to replicate that. Okay. So let me, give you a brief of the type of case studies that we'll be discussing in further slides. Okay, to give you a brief picture, this is a schematic which we developed long time back. It looks very shabby, isn't it? But then when we have presented it in a number of forums, it looked, very, very exotic when we have done that about 20 years back. Okay. So I prefer to use the same schematic, though, presently, if you are trying to look at AI generated blast furnace pictures, they look, much more exotic. But then I thought, I'll try to put up the one that we used when we are modeling the blast furnace. Okay. So to give you an overview of the blast furnace. So blast furnace is generally used for making iron ore, for iron. Okay. So what you do is, there's a huge reactor, maybe running maybe about 10 to 20 meters, depending on the capacity of this. Okay. So this particular reactor, what you do is at the top, you introduce one layer of ore, that is iron ore, and then one layer of coke. Okay. Coke is a reducing agent. So iron ore is oxide. Okay. So that ore has to be deoxidized. So you need coke, which is a reductant, which is act as a reducing agent. Okay. And then at the bottom, what you have is, several holes. Here is one section that we have just back. Okay. So these are called, tuyers. Okay. So at the bottom, you have holes all around the blast furnace. So I'm just showing only 2. But then if you look at the total circumference, there are about 30 to 40 such holes that are there going inside. And through these holes, what you do is you inject very hot blast of air. So this temperature would be about 900 degrees temperature. So you insert, send hot blast of air. It is called the blast furnace. And while sending this blast of air, what you also do is you also inject pulverized coal. Okay, pulverized coal is powdered coal. So this powdered coal, along with, and once it is injected into this hot air, okay, it instantly ignites and then gives tremendous blast inside. So this blast, once it happens, the heat transfer and the gas is going upward because it's a blast, and gases are there. So these gases, go up, okay, and while going up, they also transfer the heat that they have. And in the process, what happens is the melting happens because the temperatures reach about 2000, 3000 degrees temperature. Okay. And this melting happens. And once this melting happens, the ore gets reduced. It becomes iron, pure iron, or we call it, pig iron. And then the other unwanted portion, which because, the ore has, several other impurities, about 30 to 40% impurities are there. So that along with, the coke impurities, all these things will be there. So they'll melt and then they'll come at the bottom, settle at the bottom. At the bottom, what happens is you have, two layers that are formed. This iron that you have is has higher density, and the other unwanted portion or impurities, which we call it as slag, it is lighter. Okay, so it is elementary that the high denser element will settle at the bottom, and the lighter unwanted slag, which is the impurities, it will settle at the top. Okay, so you have two tap holes. One tap hole which is at the bottom, which will tap the iron or the metal, and at the top, you have another hole which will actually tap the slag, which is unwanted. The slag is thrown out, and then the metal is actually used. Okay, so this is basically what the blast furnace is. Okay, sorry, I'm spending a little more time because the succeeding examples will actually this. So look at what are the processes that are happening. The process that are happening is you have the gas flow from the bottom to the top, and then have a metallic flow from top to the bottom. Okay, because it drips and then it comes down. Okay, and what you also have is when the gases are flowing and the cross currents are happening, sometimes the gas, instead of going uniformly everywhere, there could be a channel effect, where it instead of going from all through, it takes only one portion. So that is something which is undesired. Okay, how do you predict that? Okay, so what we have done is, while doing the modeling, we wanted to understand what is happening inside. Like at any given point of time, if I want to know how much of ore has reduced, what is the temperature, what is the gas rate that is coming up. So to understand all these things, what we have done is we have inserted two probes. What happens is we have actually made a hole here. We have inserted a probe that goes in like this up to this portion, and then when it is withdrawn, it scoops out whatever is present there in it. So once this scooped out portion is removed, at different sections, we know what type of reaction has happened. Okay, and similarly, we also, that is called a vertical horizontal probe. We also have a vertical probe which descends from this here. It goes down, and while going down, before it get destroyed because of the immense heat, it gives us a lot of information of what is the air flow, the oxygen flow, and other things. So all these things were used for making this modeling studies. Okay, and then what we have done is, we have also made some experimental studies apart from these modeling studies. So in a live blast furnace, what we have done is we have in G blast furnace of Tata Steel and the number 5 furnace of Bokaro Steel, we have inserted several sensors, about 1024 sensors at different points, outside this. And each of these sensors would give us, information of, the different temperature, pressure, the type of reaction that is happening and all those things. Okay. So these information, once we feed it into our system, into the model, okay, we'll be able to understand if the gas flow is uniform, like here I've shown, or if it is skewed, where this is channeling effect. So all these things, we'll be able to understand through this. Incidentally, this is a picture that is generated through AI. Okay, but then we did not have these tools to understand this. So with the present, if we are able to, given a chance to do the same type of project again, because the instrumentation is already there. What we do is all these sensors, instead of having physically wired and then they are brought to our program logical controller. What we will do is we'll make them all IoT enabled, so that you don't have to physically have a cable running to the control room. So all these things would be IoT enabled, and then at every point of time this data would be there. So this data would be taken on a minute by minute or hourly basis, whatever it is. So that will help us to understand what it is. Okay. So similarly, we also try to model a submerged arc furnace. So in submerged arc furnace, instead of in the blast furnace, the heat was coming through the coal injection. Okay, here it is electrothermal, in the sense the heat is coming through these three electrodes, the massive electrodes that are there. The one that we used, it is about 1.5 meters in diameter. So three electrodes are there. So these three electrodes move up and down, and then they create an arc over here. So once this arc is there, it produces heat, and because of the heat, you have the ferroalloys produced. And then we are trying to look at the thermochemical, electrothermal, and heat transfer models, mainly to understand the strategies for optimization, whether it is specific raw material consumption or specific power consumption. And also we would like to look at some of the operational practices, like how do we put charge from the top, okay, whether it is uniformly distributed all over, when to slag the tab, when to tap the slag, how to move the electrode, and all these things. And with all these things, we created these figures, which were very well appreciated when we presented it to the Ministry of Electronics, and I think 2006 2007. They gave us a project worth about I think 70 lakhs. So we were able to create all these things. But then these things look very, very primitive now, especially with the type of instrumentation, IoT devices, and the Google platform, AI platform that we have. Okay, so with that context, let us look at some of the challenges that we need to have. Okay, so for any immersive environment that you need to have, the first thing is you need to have high quality 3D models, okay, and environment. Okay, so look at the type of models that we had. This looks very primitive. So these things would never be more appealing once we are trying to have a 3D model. So for that the challenge is to have these 3D models. So what, as I said earlier, you need to create few 3D models, feed it to this Vertex AI, and it'll start generating several models. And through this generative AI, make use of Imagine and then Dream Fusion. These are some of the tools that you can use it. And if they are integrated to Vertex AI, it will start generating a lot of models. But then all these models don't try to feed them back for creating few more models. Make your own filters. Identify which are the ones which are good, which are the ones which are not correct. Identify the ones which are relevant, which are irrelevant, and then try to come out with the chance. So that is how you have generative AI making a lot of models. Okay, and then you also need to have these artistic styles to these 3D models when you're using this. Okay, because you want to have what section of the the model that you want to have. Okay, whether you want to have a cut section from the vertical section, or you want to have a section which is horizontal section at different places. Okay, so that you need to create. So that is what the present style transfer part of it can really do it. It is in the Vertex AI. Okay, And then you can also have, this mesh simplification where you can optimize these 3D models for efficient rendering using the tuning. We talked about tuning, right? Model tuning and deployment capabilities. Okay. So once you have this, the benefit is, you have once it is properly tuned and understood and then deployed, then you have reduced content creation costs. Okay. Because only few models, maybe 10 to 20 models that you need to initially create. And after that, you keep feeding it and then selecting and then refeeding it. So that way, you have reduced content creation costs, faster development cycles, and increased artistic flexibility. Because, you can look at different sections where, you can have these images. The other one is, how do you capture, the natural language interaction? Okay. So because, if you look at this cartoon, okay, this indicates, what he has in mind, but then through verbal or non-verbal communication, you always communicate what you want to. Okay. Now, how do you capture? It could be through language, natural language, or it could be through some other means. Okay. So that is something that you need to capture. And how do you capture that? To give you an example, when we were actually working on the ferroalloy furnaces, we were talking to a very layman. He's sort of a mystery working in the shop floor. Okay. So when we are trying to understand, what the phenomena, we always give respect to the understanding or to the expertise of the shop floor persons. Okay, so we took them out for a nice place which is very close to the restaurant which is inside. Took him to a nice room. Okay, and then started trying to talk to him on trying to learn his expertise. Okay, so when we are trying to learn from him, we were talking to him. Suddenly he said, looked at the flare that has come out from the furnace, and then said, "This is the time to tap the slag." Okay. All the while, he was engaged in talking, and suddenly he says that this is the time to tap the slag. So we are not understood, what is happening. Okay. So many times, what would happen is this language is something, natural language processing is actually required to capture, some of these things. And then for that, you also need to have, proper dialogue management, because only then, you'll be able to extract the expertise that this person has. Then we started asking him, how is it that, he has understood that this is the right time to tap the slag? Then he said, I could see, what is happening, the color of, and the flare and the type, of the flame that is coming out of the furnace. So this has actually helped me, or with this, I know, that it's the time to tap the slag. Okay. As I said, slag is something, which is unwanted portion. So how do you capture all these things? So you need to have proper dialogue management. So presently in Google Vertex you have prompts which through which you can keep prompting them and then trying to extract the type of right answers that you want to have. Okay, and then this sentiment analysis is also something that we need to understand. So this will help us creating more personalized and responsive interactions. Okay. So the benefit is that you have more believable and immersive character interactions, enhanced user engagement. So this is what I have emphasized. By talking to the shop floor person, you have enhanced user engagement and then improved user experiences that are as well. Okay? Now, sometimes what happens is all that you see may not look very rosy. Okay, like this cartoon says. The failing grades you'll be seeing won't be virtual. Okay, so so that's the type of message that you need to look into, because the challenge is immersive applications often need to understand the user's environment and the objects within it. Okay, so you need to understand that. This is also we said that you need to have a domain expertise with you. So in the previous example, I said that the domain expertise could be a shop floor person, A domain expertise can also be a metallurgist who has done doctorate and then published large number of publications, or a domain expertise can also be an engineer who goes through the log sheets of what is happening. Okay, so the solution for this, you can have object detection that happens in Google AI. Okay, where you can train the custom object detection models by data labeling and vertex training. So this is where I said labeling is very, very important in one of the earlier slides, because that will actually help you with the image classification. If you do not have proper data labeling done, then the image classification, though this feature is there, this will go for a toss unless proper labeling is done. So you need to understand the importance of labeling. Okay, so this image classification will actually classify different scenes and objects to provide context. Okay, because the context is something very, very important. You may see a blast that is coming out, the color and other things may be the same, but then the context is very important, because if you know the context, you will be able to understand, like the shop floor person, that this is the right time to tap the slag. Okay, so that will be able to capture some of the intelligent actions that are there with the domain expertise. And also this will help you come out with proper estimation, where you can track and position the orientation of the users and object for realistic interactions and accurate augmented reality overlays. Okay, so if you had a tool looking at the all the sensors that, as I said, if we had IoT based sensors, maybe we would have created an AR overlay where all this data would go into this. Okay, so again, the benefit is the context aware experiences, improved user interaction, and enhanced realism. Okay. The next thing is, you need to have personalized and adaptive experiences. Okay, you cannot always say that I can learn from my mistakes is the right approach to education. So this way, what happens is you need to wait for a mistake to happen and then learn. Okay, so present day generation, doesn't give you that liberty of failing time and again. So the challenge, the providing engaging and effective requires personalization, adaptation to individual user needs. Okay, so you cannot say that I'll adapt slowly, or I keep failing and then try to adapt. So this liberty is no longer there. So the solution is you have the recommended systems where you have the engines to suggest relevant content, what are the activities, what are the learning paths and other things, and then also try to be adaptive to the difficulties that are there. Okay, so just like looking at different types of challenges that you have when you're actually say playing something on a game, at different levels, isn't it? Expert level, master level, or something, or a novice level. So that would actually help you looking at the difficulty. And then there's also a personalized learning path where you have create customized educational experiences based on individual learning styles and goals. So this is where the basic engagement the benefit is, if you are able to do some sensitivity analysis. As I said earlier, sensitivity analysis is look at different parameters that are affecting a process, and then change one, and then you want to see what is the effect of the others, then change two, and then look at the effective of this. So this will actually help you increase user engagement and improve learning outcomes. Similar example, similar learning would also help you in making a digital twin analytics, where you are analyzing the data from physical assets and optimizing their performance. That requires powerful analytic tools. So if I had the type of tools that presently are there, or if the ministry, whether it is Ministry of Information Technology or the Ministry of Mines or Steel and Mines, if they now give us an opportunity to look into these have more immersive environment, we would happily take it, because now we can always create a digital twin analytics okay, where you can really help. We can a lot of learning will be there, especially by conducting a lot of sensitivity analysis. So this sensitivity analysis that you do will help us, in predictive maintenance, or coming out with some prediction. Okay, it will also help us, in anomaly detection. I talked about, the channeling that happens in a blast furnace. So if there's any anomaly that happens, it can always try to look at the detection by looking at, the unusual patterns that happens in the sensor data. So the sensor will pick up this data, but then if you are the thousands of sensors, if you are working, it will be very difficult for you to sit on and then try to analyze each of these data. But fortunately, for all these things are down to the Vertex AI, any unusual pattern and behavior that is happening in the sensor data, anomaly will be detected, and then you will immediately have an indication that something is happening. And further, more importantly, the performance optimization would happen. I talked about the type of optimization that we attempted when we are trying to look at the process simulation data, where we said we looked at the specific power consumption. So what we mean by specific power consumption is how much is the power that is consumed per ton of metal that is produced. So this will actually help us in by doing a lot of sensitivity analysis. We'll be able to come out much performance optimization, so that we have better power consumption, specific power consumption, and specific raw material consumption. So this is something, one of the benefits that would come out of digital twin analytics. Okay. To do all these things, I think some things are, very, very important. Some of these technical considerations and the best practices. You need to have, proper data. So this data can come from, different sources, as I mentioned. It could be coming from the sensors. It could be the data that is coming out from by talking to a sensor, by talking to a shop floor person, by talking to an expert, or talking to an engineer, or it could come in the form of the records that are there, the log sheets that are there, or it could be some videos that are there, because if you want to identify whether the type of color that is required in the flame to find out when to tap. So all these things would be there, and the data preparation would be required, and these things would help us help you with the optimization, which would actually try to minimize the latency, especially when you're working on a real-time environment. Okay, like we did when we made this real-time process simulators, the data would directly come on to online data would be coming, and this online data would go into our models, and then the prediction would come. But then looking at the data that we were analyzing and the type of computing power that we had, we were able to make a prediction or analyze the data in about 20 minutes time, and then the prediction would take another 20 minutes. So that's the reason, though the sensors are actually are giving you data on a minute to minute basis, we were only analyzing and then giving prediction after 1 hour. Okay, so that latency can be minimized if you have a tool which can look into these things. Okay, and of course this will also lead to cost optimization. Okay, and the security and compliance would also be there, making use of these are some of the best practices that you have. Okay. And these I think I've talked about earlier. So let me to consolidate, whatever we have said. The Vertex data labeling. So as I said, different types of data that we obtain for this process. We try to label it. We need to label it and then feed it, and then these things, data would go into the training. So all this data that you need to identify, have a domain expert say that this data is relevant, this data is relevant, this data is correct, this data is wrong. Okay, and once you have that, then you have all these DLL and other machine learning techniques which will help you with the training. So you come out with a training model, you come out with a predictive model, and then you come out with a forecasting model. All these put together will help you come out with better prediction, and then you will be able to automate the Vertex pipelines. Okay, so the entire machine learning cycle flow would be there for you to understand and then analyze. Okay, and then create a managed development environment. Okay, And finally, pre-trained models would be there to pre-build the solutions to for accurate development. Okay. Now, I just gave you an give
So,
you an
excuse me,
example of
sir. Excuse me, sir.
yeah.
That pre-trained models are available based on the software which we are installing and proceeding with different environments. That pre-trained model available, or we have to prepare a model which can called as a pre-trained.
Anything you're doing for the first time, you need to create the model, right? Okay. So even when we have made this blast furnace modeling, what we have done is we had a rigorous model at the back end, which would actually take maybe about 1 week for us for it to give the results. So this based on that model, what we have done is we have created a reduced order model because we are making it for real-time process simulator. Okay, so real-time process simulator, it cannot wait for about several days and then come out with a prediction. So we have created a reduced order model. But then this reduced order model, what we have done is we have validated it and then found out it is correct and then used it. Okay. So to answer to your question, now if we can, because we already have these models that we developed earlier, so they can become the models, pre models that we can feed into this environment. Okay, but then how accurate are they? Because these days we are talking of much more accurate things. Okay, if these things are not there, you have to do a lot of iterations, make these models, and once these models are available, yes. Okay, you can go to any blast furnace. Presently, supposing we have done it for the Tata Steel G blast furnace, we have fine-tuned it. We have done it perfectly well. So this data, okay, now we can use it in any other blast furnaces because the overall working would be the same. So you have this data already ready available. So pre-fed data, or what the word that you have used. Okay, so this data is already available. We can use it. Okay. So did I answer the question?
Yes, sir. Thank you. But here only, as far I understand, the process and control application only we are maybe which we are understand based on some of the examples which you've done very well. If suppose I want to divert to some other area which can concentration on artistic effects or some other type of musical systems effect which can I prepare by the help of our immersive technology principles. Is it possible, sir, in such a way?
Yeah, it is possible. What you need to do is, fortunately, you don't have to create data. So, if, for example, you want to create a tune which is based on Rag Bilahari. Carnatic music?
I heard, sir.
Okay,
I heard.
so there are several ragas. Okay, so each, say for example, there are some hundreds of ragas are there, and then each raga is set to a tal. Okay, so Adi tal, Teen tal, and all these tals are there. So what you need to do is feed this vertex with different musical compositions of Bilahari raga. Okay, set to different laya or tala. Okay, and then ask the Google Cloud, or the Vertex, to create a new tune for you based on this raga. Okay, so it will learn from this, and then because it has learned and then it has understood what this raga is, when it will create a total original content, okay, which is different from any other thing, but then again following the same raga. Okay, so similarly you can also say create a raga which is based on some Bilahari and then maybe Averi. So it can read all those data. Feed, what you need to do is you need to feed different musical composition set to these ragas, and then it will create it. Okay, so that is how you can take any example for that. What you need to do is have the data fed into it and then ask it to create a new content for you, so that it will be able to do. Okay.
Thank you, sir.
Okay. Yeah. So I've just given an example of the process control system, but this example can easily be extended to any field. Only thing is, instead of the blast furnace, you have, if you are looking at, healthcare systems, then, you need to replace this blast furnace with a human body, identify, different parts, have an expert, in which can who can identify these parts, the nervous systems, and then you can have, these immersive environment, made. Okay. And if you are a musician, you can also create, new music and all these things. Okay. So
Thank you,
let's
sir.
look
If
at,
possible, yeah, thank you, sir. If possible, at the end of the session, can you show some practical live, any Google link, something can share to us? We'll go ahead. Even the process control examples also, it is very useful to us, sir, because we done what we called six walls control system and level controls, conical tank control systems and all. So that's what we are requesting from
okay,
yours, sir.
what is your
If you
background,
have
by
any
the way?
link.
What is your
Sir,
background, by the way?
actually, myself is electronics and control engineering, sir,
Great.
and I done my PhD in electronics and communication systems only. But my postdoc, please, AIML.
Okay.
So I was concentrated on multidisciplinary uh, applications, sir. That's what I concentrated.
Yeah,
Thank you.
I think you are the right person to, venture out and then make these process simulators for all these industries, because you have good background of control systems. You also have good background of electronics, because you can work on IoT devices. You also have, background on AI and ML. So this is the right type of expertise that is required for making, these things. Only thing is, you also need to carry a domain expert. Once you have network with them, I think sky is the limit for you to, create the type of immersive environment which everyone would actually lap up and then take it forward. Okay.
Thank you so much for your kind blessings, sir. Thank you so much,
So
sir.
what I'll do is, maybe after this, I'll try to, send some of these links to Dr. Sunita, which some of you, all of you, can look into it. Okay. So let's look at the final thing, how to create the code using Vertex AI. Okay. So first, of course, you need to do a setup. In fact, I had, several slides prepared on this, but then I'm not going into that. I'll just give you one slide after this, because, fortunately, all these things are done by Google Cloud, by Vertex itself. So first thing is, you need to set up. You need to have, proper authentication of the environment that you're using. Now these are the libraries. So these are the libraries are, a predefined, or, either it could be graphics, or it could be the knowledge that you have acquired, if it is a process, or, the type, your expertise in music, or, on human anatomy and all those things. So the libraries must be there, and you have to have an immersive framework, error handling, and how do you look at it? This is what, as I said, the error handling is very important. The expertise of domain expert would actually come here, and then finally the model deployment. Okay. So of all these things are there, then I think let me give you just, try to make an object detection using a deployed Vertex AM. Okay. So if you try to, make the code, so this is the long code, that you'll have. Okay. But fortunately, the Vertex itself will be able to create such codes, and not only create those codes, it will also give you the explanation. So I just gave you a snapshot of, what all this Vertex AI model can do. So all you need to do is, give it the right type of prompts, and then ask it to generate codes. So even without codes, if you're able to do it, come out with the right prompts, it is fine. But then if you are actually trying to fine tune the model that you want to have, I think it is better, that you go through this code. So this code, it can make it in Python, it can make it in Java, it can make it in and C++, whatever it is, you want, it can make into those things. In addition, as the beauty of it is, it can also give you an explanation of what this code actually means. Okay. So this is the snapshot that I have given. So with this, I'll try to end my conversation with all of you. Okay. This is my concluding slide. Let's, I think, on a more, I want to end it on a more philosophical way, because what happens is, when we are trying to, look into our own world, you will be like a caveman in a Plato's allegory in this cave. So in this cave, what you have, is some cavemen who have never ventured out. They have never not seen what is outside world. And what they have in front of is, as a huge wall or, a cave wall. Okay. And they cannot go there because there is a barricade here. And in the process, what happens is, if there is any small object which is moving in the hole from which the sunlight is coming. Can you see my cursor moving? Can you all see my
Yes, sir.
cursor moving?
Yes, sir.
Yeah.
Yeah, yes, sir.
Yeah. So if any small object moves, then what happens is it is magnified several fold and then it falls here. So once you look at these images, what happens is, if you are living like a caveman, you're afraid to go out and then venture out what is there outside. Okay. So that fear of failure would step in and then you'll never try to come out. But then once you conquer this fear and then come out and then see what is outside, you will see that you are much bigger. The knowledge that you have is much bigger than what others possess. Okay. And for that, what you need to do is come together, collaborate, gather the strength, and to come out. Okay. So don't live in a world where you are confined to certain things, and then keep thinking that outside people are very, very, very brave. They are very great. Okay. So come out of that, because you to do that, what you need to do is you need to collaborate, and then the innovation would actually come out. And further, if you look at the world and look at the stars that are there up on the night sky, it looks totally chaotic. There's never no. It looks a lot of stars are placed randomly by the God, and like the famous quote of Einstein, he says, "Does not God does not play dice with the universe, because any object that is there, any star that is there, if it is moves by a few centimeters, I think the whole world will collapse." Okay. So don't think that whatever is there is chaotic. There's always a method in the madness that you see. All you need to do is you need to unravel this madness and the method that is there behind it. Okay. And for to do this, you don't have to go anywhere. Look at your own body. Okay. Your body has everything that you want, that you need to discover. Okay. It can generate energy. It can consume foods. It can make foods. It can act against different types of viruses. Okay. It can extract metals from the food that you eat. It can extract calcium from the milk that you take, and also distribute it to the right place. Okay. So all these things are happening within our body. So try to look at what is happening inside, and then don't be overawed by what you see from outside. People don't think that people are outside are gigantic. So come out of that cocoon, and then the world will be theirs for you to prove. Okay. Thank you so much. So any queries, I'll be happy to take. And this presentation will be there available with you. You will be able to look into it. Okay.
Thank you so much. It was such an excellent presentation. Now I request the participants, if you have any questions, you can ask.
Sir, as per your kind suggestions, and later you are going to be shared some links with coordinates. Kindly, sir, please, sir.
I'll do that.
Thank you.
And
Sir.
my email is also there. I think I have a similar expertise, the ones that you have. Okay. So maybe I think we can interact sometime later. What's your name, by the way?
Sir, my name is Dr. Polaya Bajja, sir. At present, working as a professor in Sri Institute of Aeronautical Engineering, sir, Dundikal, Hyderabad.
Oh, you're from Hyderabad. Okay.
Yeah.
I am also from Hyderabad, so maybe we can
Definitely,
find
I'll
some
come
time
and
to
meet
meet.
you sometime, sir. Definitely, I'll come to meet you.
Please.
So kindly send me your email ID in the chat box, sir. We'll come.
It is also there on my slide, but then let me put it there in this. Okay. Yeah, I posted it. And it's
Thank
also
you
there
so
in the
much.
slide, which
Thank
I'll be sharing with Dr. Sunita.
Once again, thank you, sir.
Yeah.
Participants, I request if you have any questions, you can clarify with the sir.
Yeah, I think it's almost dinner time, right?
Yes, sir.
Okay.
Thank you so much, sir. I hope there are no further questions. Okay.
So,
സബ്മിറ്റ്
I think,
ചെയ്തോളാം, ഞാൻ നാളെ പൊക്കോളാം. എന്ത് ദൈവമേ ഇത്
okay. Good evening, everyone. As we wrap up today's faculty development program, I want to express my heartfelt gratitude to all the participants and the speaker for their dedication and engagement. We have dwelled into cutting edge topics like immersive technology, AR, VR, digital twins, cloud, Google Unified AI platforms, and Vertex AI, gaining valuable insights into their application and future potential. I hope this session has sparked new ideas and inspired further exploration in these transformative technologies. A big thank you to Dr. Satyanarayana Nanduri sir for your sharing expertise, and to everyone who contributed to making this FDP a grand success. On day 4, on this FDP, we dive into blockchain technology and Metaverse. The speakers are Dr. Noor Muhammad, SK, Associate Professor, Indian Institute of Technology Design and Manufacturing Technology, Kanchipuram, Chennai, and the title is Blockchain and Ethereum in the Metaverse. Another speaker, Dr. Gururaj HL, Associate Professor, Department of Information Technology, Manipal Institute of Technology, Bengaluru. His title, NFT and Smart Contracts in the Metaverse. Thank you once again.
yeah, I think let me have the last word. Okay.
Yeah, sure, sir.
Let me thank
Sure, sir.
the JAIN University. Okay. I think one of my associates was working there, and I don't know whether he's presently there or not, is Dr. Ranganathan. He was earlier working at JAIN University, Bangalore. Okay. And we were the ones, who worked on some of those metallurgical reactors. I don't know whether he's still there or not. Okay. So we were together when we were working at National Metallurgical Laboratory. Let me also thank Dr. Sunita and your Naveen Jain, right?
Ram Kumar, sir.
Ram Kumar.
Krishnamurthy.
Okay, Ram Kumar. I think nice of you. And let me
Thank
also
you, sir.
thank your Vice Chancellor and JAIN University for inviting me. Okay. Finally, to the participants, anytime, you can just push a mail. Okay. I'll try to respond to any of your queries. Thank you so much. Goodbye.
Thank you, sir. Now I request the participants, please turn on your camera. We can take a group picture.
So is it done?
Yes, sir. Thank you so much, sir. Thank you so much once again,
I'll take-
participants.
Thank you, sir. Thank you so much, sir. Good night, sir.
Thank you so much, sir.
Dear participants, this feedback link will be active till 20 more minutes. So please fill that form as early as possible. Thank you.